All right, I'm going to go into visual, domain, and range. All right, so do remember that domain is your x-axis and range is your y-axis. All right, so determine the domain. I am going to answer both questions while I go over it instead of just the question I'm asked, because you can be asked for range or domain. So I'm going to do both just in case that's your question. So in my question, they're only asking for the domain, so I'll only put the domain. But here I'm going to work with them both out. So remember, domain is which values? Your x values. So go to the end of the graph on the left, right here. And actually, I'm not going to put that there. What is the number? Because it's my x values, I have to go up to x. -3. So I'm going to do domain -3. And then go to the furthest point on the right-hand side. The furthest point of the graph on the right-hand side is right here. What's that x value? And it has to be x because it's domain is 5. Okay, then you have to deal with whether it is open or closed. So let's look at it. At the very end of the graph, is it open or is it closed? It's closed. So remember, closed is a closed bracket. Open is a parentheses. All right, so closed is a bracket. So this would be actually my answer. So I'm going to put it in here so I don't forget, and then I'll do range. So I come here and I look for, it's going to be close, close. So I look for close, close, this one right here. Then I just put in my numbers. So -3 and 5. But I'm going to go ahead and do the range as well. So that one is for domain. I'm going to go ahead and do range. So range, instead of it being x, my range is going to be my y value. So I don't care about this axis at all. I only care about my y. Okay. So for range, remember, it's from the bottom to the top. Okay. So let's do that. The bottom of the graph, the very bottom of the graph is right here. Okay. So you go to the y-axis from the bottom of the graph, you write the number down. You go to the top of the graph, So boom, boom, boom. What is it doing? It's a line right here, right here. It's the top of the graph. You go to the y value there. Then you need to see, is it open? Is it blank there or is it closed? So I can see, if you look, so I'm going to erase this real quick so you can see. If you look here at the top, it's closed. But even if this was open, right here, it's closed. Right? So it's closed because there's a blue line at that point. So it is closed. So remember, closed brackets, if it's open, it's parentheses. All right? And over here, it's also closed. So this would be my range. Now, if you have infinity, that's always open. Okay? But I'll do another question. Hopefully this one has 2 that I can do. Let's see, next problem. All right, now it's asking me for the range. So again, the same thing. The bottom of the graph, -9. The top of the graph, -4. So -9, comma, -4. And is it open or closed? Closed and closed. So this will be closed, closed. I do want to find one that is open. So hang on 1 second. It won't let me do another question, but maybe show example. Okay, here's one that's open, right? So this one, domain, will be left to right. So left of the graph, -4, right of the graph, 7. So -4, 7. And the left of the graph is open, and the right of the graph is open. So it's open, open. See, open, open, and then -7, -4, 7. Let me find another example. This one's open, open, -7, 8, domain. Find another example. Domain again, this one is closed, closed, -4, 8. Closed, closed, -4, 8. All right, do one more. This one's open, open, left to right because it's domain, right? -11, 10. Open, open. All right, range. I'll do this one more time. Bottom to top. The bottom of the graph is right here, -9. The top of the graph is not here, right? It's up here. Top is -1. And at this point, there is a blue line. So these dots aren't original in the graph, but the blue line goes through it. So it's closed, closed. All right, so I want to take a look at select form to find quadratic feature. I'm going to specifically look at just increasing and decreasing. Okay, so the first thing you have to do is decide what form that you need it in. So vertex, factored, or standard. So think about what it means for something to be decreasing, right? So here's a graph of a quadratic feature. All right, this is increasing over here. When I get to this point, I start to do what? Decreasing. So this is my turning point. What is this called? This is my max or my min, but also it's called my vertex. So what I really need is my vertex form. All right, so vertex form, and this is going to tell me, okay, so I just need to graph whether it's a happy or sad, and then I can pull my vertex out to see what it is. So my vertex right here would be the opposite of that, which is -4, comma, +8, right? And because it's sad, it'll be increasing on the left of that and then decreasing on the right of that. Of what number? Of the x, right? However, this is me showing you how to cheat with a calculator. So we're actually just going to cheat with a calculator. So we're going to take our equation and we're going to paste it, Control C and Control V. It's going to look weird, but all it is the squared function is different. Shift 6 is going to get you the squared function. Control X, Control V is going to paste. Again, you can just type it out if that's faster for you, but always double check to make sure you have the same equation. So this is the quadratic we're looking at. Where is that decreasing? So again, the definition, this is increasing, and then this is decreasing. So everything to the right of this. Now, the cool thing about this calculator is I can check my answer. I'm saying it's decreasing everywhere to the right of -4. So everything to the right. So this is right, this is left, right of -4, or everything greater than -4. I don't like black, so I'm just going to change this color real quick. Red. Okay, fine. We'll do red. Don't like that color. Blue is better. Okay, so I'm now going to check it. So I put my answer in here first before I submit it to check. Is it decreasing where it's shaded? Do you see the line? And I guess I should make them blue. Let's change the color there, green. All right, do you see where you see in the green part here and the graph, is it decreasing? Yes, so this is the correct answer. All right, so you're just going to Control C, Control V, your answer, and submit it. I'll do one more just to make sure. So similar problem. Let's do an increasing one. Increasing, okay? So again, it doesn't even matter because if you're cheating with the form, you can select any form. So you're supposed to select vertex form, but you can really select anything. Control C, Control V. All right, it's going to look a little weird. Fix it. So we need a squared, Shift 6, 2, and then copy this, Control X, Control V, and then double make sure that this match. Okay, this matches. To zoom out, Control minus, or you can pinch your mouse in and out like I just did. All right, so again, I'm looking for when it's increasing. So let's look. This is decreasing. Then it starts to increase. So it's increasing after this point right here. So anything after this point, so anything after 4, so x to the right of 4 or is greater than 4. So we're going to say x is greater than 4. And if it shades where it's increasing, I'm good. Boom. And it does. So you see, everything to the right is what I'm looking for, right? That's the increasing part. So again, this is how you check your answer before you actually submit it using this calculator. I'll just do one more because that was kind of similar. All right, so this is a decreasing problem again. Do vertex form. Change this part. Copy that on here. And it's +8. All right, so once again, this is my quadratic, right? And I'm looking for when it's decreasing. Why is everything to the right? Okay, I'm trying to look for one to the left. So actually, let me do a different question. Similar problem. This one is when it's increasing. Let's see, this one, x + 1 and +32. All right, and this is increasing. Okay, perfect. Let's do this problem. So again, copy and paste. Now I'm looking for when it's increasing. Again, you can zoom out a little bit. You can zoom out so you can see it. So here it's increasing and then it starts to decrease. So my turning point is right here again, the vertex. So on the left side is when it's doing this increasing side. So I think the answer should be on the left side of whatever your vertex is, which is -1, which again, you can pull right out of this equation, okay? All right, so is the shaded part, before I put my answers, is the shaded part the increasing part? Yes, it is. So this is the correct answer. Control C, Control V, submit. Yay. All right, so we're going to take a look at, all right, so select form to find quadratic feature. This time we're focusing on positive and negative. So we're going to click on that. I need positive and negatives. Okay, so here's a question. Select when it is positive. You have to know what form to use. So let's talk about what negative and positive means. All right, so positive is anything above the y-axis. The x-axis. Positive above, and negative is below. So anything above is positive, anything below is negative. Which means what are my true crucial points now? This, because these 2 points will tell me above here and then below these 2 points. So these points are called x-intercepts, which means when I come here, I'm going to choose factored form because that will give me my x-intercepts. And you can see them already without me even doing it. My first one is going to be 1. My second one is going to be 3. However, I will go ahead and put this in. So Control C, Control V. All right. So again, like promised, -3 and 1 are my x-intercepts. All right. But you still need to draw whether it's happy or sad. This one right here, sad, right? For you to see. So here's your sketch, but this is actually how you check it on the calculator, right? So these are my 2 points. So if I'm looking for positive, it is above, right? And remember, positive is above the x-axis. So is this together or separate? Together, because it's one thing together. So if you're putting in a together answer, remember you put the x and you put less than on both sides. And from order from left to right, you put your x-intercept. So it's -3 and then 1. So you're going to put -3 and then 1. And if it shades, so before I do this, if it shades in the graph, that's what I was looking for. So this is the correct answer because you can see the graph is shaded in. All right, and we're going to do another one, of course, just in case you need it. All right, so new problem. All right, so let's do another one. Let me find one that's actually a negative. Similar problem. This is y-intercept. Why is it asking me for y-intercept? Positive and negative, similar. All right, good. Here's a negative one. All right, so here's the question. Again, if you're dealing with positive and negative, I need to know my x-intercept. So that means I look for factored form. I copy that and then I paste it. Make sure it's exactly the same. And then I need to know if it's together or separate. So I'm looking for negative. So this time, all right, underneath my 2 points, this is negative. Is this graph together or is it separate? It is separate because I come up and then I stop, and then I come here and I start going down. So separate. Separate means I should have 2 equations. All right, so 2 equations. One is going to be to the left of this number. So this part right here, right? Left. So I say 1x is left of, and if I do this correctly, it's going to shade this part of the graph right here. This is what I need shaded. So to the left of -5, boom, just like that. You see that? The graph is shaded. So it's either this one or, right, now what's the other one I need? I need it to shade this part of the graph to the right of -3. So to the right, and you can just use this, of -3. And if I do this correctly, it's going to shade this part. This is what I'm looking for. Boom, just like that. So you see, my negative, all right, underneath is what is shaded. So these answers are correct. And that's how you use the calculator to check your answers before you submit. And you have this calculator, so definitely go ahead and use it. All right, we're going to move on to end behavior graphically. So remember what that is. End behavior is just what's happening at the end. So this one is not something put in the calculator because you can see it. What's happening at the end, this is going to infinity. What's happening at this end, this is going to negative infinity. So on the left, when x is going left, so this is left, right? On the left side, it's going to infinity. So it's either this one or this one. And then on the right side, it's going to negative infinity. So this is going to positive infinity. This one is going to negative infinity. All right, I'm going to do one more just to make sure you're okay with that one. Again, what's happening at the end, whether it's left or right, both of them are going where? To negative. So it doesn't even matter what this one is. I'm just looking for negative, negative. I might need to make this bigger. I'm looking for negative, 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 negative right here. Because it doesn't matter whether it's left or right. Matter of fact, I'm just going to do one more just to make sure. All right, again, I'm looking for, this is going on the left, negative, on the right, negative. So I'm looking for both of them to be negative, negative, negative. I'm just going to do another one because that was the same as the other one. Oh my gosh. New question. Oh, that's the same one. Okay, new question. All right, how about this one? What's happening at the end? At the left, it's going to positive. And here, it's also going to positive. So I'm looking for going positive, positive. Positive, positive right there. All right, let's do one more where it's different. So that's the same. Here's different. This one's going to negative on the left and positive on the right. So I look for x is negative. It should be going to negative. So it's either this one or this one, and then positive on the right. That's negative, and this is positive. All right, I'm going to do one more. Again, this is going to positive on the left and negative on the right. So I'm going to look at, for the left, this is not the left, this is the right. So be careful. So this is the left. On the left side, it's going to positive. So on the left, it's going to positive. So it's either this one or this one. On the right, it's going to negative. So on the right, it'll be negative, this one. All right, next question. All right, adding and subtracting integers. Okay, so since we have a calculator, we're just going to Control C and Control V. And whatever all these extras are, you can always just X them out. It literally doesn't give you the answer if you do that? Really? That's kind of deep. All right, well, negative times a negative will make a what? A positive. Oh, wait, it did give me the answer. Okay, I don't know why it didn't show up before. So -7. That's why I use the calculator on addition and subtraction. Yay. All right. Question 7, evaluate. So you're going to, again, Control C. You're going to take your question, put it in the calculator. Make sure it copied the question. Then what does this mean? You see where the x is, right? In place of x, because you see it's f of x, in place of x, you're putting what? -3. So I'm going to copy the -3. Where I see the x, I'm going to delete that, put a parentheses, and put -3. So this is -8. All right, so I'm going to do another one. Let's just see if it gets really hard. I guess it doesn't really. All right, so it doesn't matter what it is. So again, copy it. You're evaluating the function. Again, what does this mean? H of x. So where I see x, find h of 3. I'm going to replace it with 3. So I copy the 3, and wherever I see the x, I'm going to delete it, put parentheses, and boom, -8. Okay, that's how you evaluate a function using the calculator. Then we have determine if a set is a function. So this one, you're looking for the x values. Are the x values repeating? So you just look at all the x values. So you have these, this, and this. Is that, and it's saying what it does not represent a function. So this one is a function because they're not repeating. What about this? -3, -8, -3, and -3. That one is not a function. I'm just going to check the rest of them. 6, -1, -7, and 3, not repeating, so is a function. 3, 2, 9, and 4, not repeating, so is a function. So the only one that is repeating is this one right here. So a function is you can draw a vertical line test, or you can just look at whether the x is repeating or not. All right, then we're going to go to determine if the graph is a function. This one, you don't need to cheat through it. It's a function if you draw a vertical line and it doesn't go through both points. So this one goes through both points, right? So it goes through here and it goes through here. So is that a function? No, it's not a function. All right, so not a function. So if it was a function, it only goes through one point wherever you draw your vertical line test. All right. All right, we're going to go to function relation and map drawing. So this one is not really a calculator question. It's just understanding what it is. Remember, this is a girl and this is a boy. A girl cannot have 2 boyfriends, but the boy can have 2 girlfriends. So I'm going to say it again. X is the girl. This is the girl. This is the boy. A girl cannot have 2 boyfriends, but a boy can unfortunately have 2 girlfriends. So again, I don't make the rules. This is just the math. All right, so let's look. This girl right here, -3. How many boyfriends does she have? She has 1 boyfriend. He's called number 1. This number 2, this girl, number 2, how many boyfriends does she have? She's got 2 boyfriends. Can you have 2 boyfriends? No. Therefore, this does not represent. All right, so let's look at another one. Here are my girls. All right, -2 girl, 1 boyfriend. Good job. 3, 1 boyfriend. Good job. -4, 1 boyfriend. Good job. 8, 1 boyfriend. Good job. Look at this boy right here. He got 2 girls. He's dating 2 girls. Is that allowed? Unfortunately, it is. Don't agree with it, but this is the math. That is allowed. Therefore, this is a function. since all of these numbers, so for each number, so for every girl, right, in my girl set, so set A, the input, there is one boyfriend. There is one boyfriend in set B, the output. All right, so let's do another one. That's the same kind of question. Let me find one. All right, boom. All right, so again, my girls cannot have two boyfriends, unfortunately, in this math lesson. All right, so 0. Look at 0. Oh, man, 0 is dated number 9 and is dated number 6. Can that happen? Not in math, okay? I'm not saying anything about real life. So it's not a function since the number 0, this girl. So is it every number? Is it each number? No, because number 7 is dating one boy. Number 1 is dating one boy. It's just number 0. So for one number, so for one girl in set A, the input, right, where there is multiple mappings because she's dating two boys, to set B, the output. All right, let's do it again. Look at this, number 5, she's dating two boys, so automatically not a function. Why? Because there's one person here, so for one number in set A, the input, she is multiple mapping to two boys, the output. All right, let's do another one. All right, let's look at this one. All right, so again, looking at my girls. All right, girl number 1, called number 1, she's dating -1. All right, 5 is dating 7. -3 is dating -1. Now, it is not this girl's fault that this boy is dating both of them, okay? So again, a boy can date two girls, but the girl can only date one boy. So this is okay. This is a function because each of these girls, so each of those girls for each number in this set, right? So in set A, the input is dating, right? Only one boy. So one boy in set B, the output. All right, so we'll take a look at finding basic patterns from a table. So what is the pattern? What's happening from 11 to 16 to 21 to 26? I'm adding 5 each time. So if I do 26 plus 5, I get 31. But of course, since we're doing this in a calculator, we're going to do the second number minus the first number. And you can see it's 5. Then I'm going to check. So start with the first number, and I'm going to add 5 each time. When I add 5 each time, do I get the next number? So 11 plus 5, do I get 16? I do. If I add 5 again, do I get 21? I do. If I add 5 again, do I get 26? I do. So if I add 5 one more time, I will get what's supposed to go in there, which is 31. I'm going to do it again. Submit. Okay. Don't know why it's not submitting, but that's fine. So we're going to go over to a new problem. All right, again, so find the pattern, what's happening each time. So this is going up by how many? So again, using a calculator, we find that difference by taking the second number, subtracting the first number. So I'm thinking it's going up by 8. So we're going to check that. So starting with the first number, 16, I'm going to keep adding 8 to it. And when I add 8 to it, I should get the next number. So do I get the next number? I do. If I add 8 again, I should get 32. If I add 8 again, I should get 40. And so if I add 8, I'm going to find my missing number, which is 48. I'm going to try and do one that has negatives in it just in case. So let's find one that has some negatives. Okay, let's do this one because, again, you're looking for the pattern. So what am I doing to get from here to here, then here, then here? So whatever it is that I think, I'm going to put it in the calculator. So I'm going to try to see if this is going to work. So if I did 9 times second number minus the first number is 6. If I start off with the first number and I add that 6 to it, do I get the next number? I do. If I add it again, do I get 15? I do. If I add it again, do I get 21? I do. So to find it one more time is 27. So it doesn't look like they really have negatives in here. So I'll do this one. How do I get from this number to the next one? So again, you start from the second number, which is -2, subtract the first number, which is -4. So it's going up by 2, so I'm going to check that. So I start off with the first number, and then it's going up by 2, so add 2. I get the next number. If I add 2 again, Do I get 0? I do. If I add 2 again, do I get 2? I do. So if I add 2 one more time, I'm going to get the missing number, which is 4. All right, hopefully that was enough for you to understand that one. All right, moving on to my next one. All right, finding slope graphically. Okay, so again, since this is cheating, we're going to cheat. Okay, so let me go ahead and pull it up. Now, on this one, you do have a formula sheet, so I'm going to Google it real quick, but you do have a formula sheet, slope formula, but I just want to show it to you. All right, here's your formula. So what I'm going to do is I'm going to copy the formula here. Now, I'm going to put the letters, these y2 and y1, x2 and x1 in parentheses. But notice what happens. So that's the top, right? Then I'm going to hit divide. Look at that. That's not what I'm looking for. So what it is I'm going to kind of readjust this. You have to start by dividing first. So hit divide first so that you don't have to, run into this problem. I'm going to click back up here and go minus. There's a letter there, parentheses, minus parentheses. Okay, cool. So I'm set up. So all I need to do is find the x and y values for the second point and the first point. All right, so since this is cheating, I'm not just going to show you how to simply just, rise over run, because that's what you should do. We are cheating, right? So I just need to find 2 points. What are 2 points? So if I look along this blue line right here, right, I need to find a corner. So you see right here, that's a corner. What's the x value? -6, and y value is 9. So I'm going to write it over here just so you don't lose track. -6, comma 9. X and y. I need how many points do I need? 2. So I'm going to keep coming down until I get to another corner right there. This is a corner. How do I know it's a corner? Because you see how it's going through it, right? So this is -2 and 6. So another point is going to be -2 and 6. So once I have my 2 points, all I'm doing is putting it in the formula. So I'm going to come back here so that you can see the formula. All right, so let's call this number 1 and this number 2. Okay, so I start off with y2. So the y2 is this one. I'm going to take that one, and you see how it's disappeared, so I don't copy it again. Put it in y2. And then on the bottom, I'm going to take x2. So again, in the second point still, the x value. So here's my x2, and I'm going to put that where? At the bottom. So I'm just matching. In my first point, I'm going to take y1. So y1, this is y1, and put it where y1 goes. Control X, Control V. And the only one left is x1. So I'm going to take my x1 and put it right there. Boom. All right, now if you try to put this in the calculator, that's going to be wrong because you have to leave it as a fraction. So how do I turn it into a fraction? See this key right here? You click that, that's your fraction. So you put in your answer as -3 divided by 4, and you click submit. Oh, okay, so it makes you, okay, so it does force you to do the rise and run before submitting. Okay, so remember, I'm going to put my 2 points. So here my 2, it was this one to here, right? So my rising and then my run. So it's, you see how it warned me, right? I got to go ahead and plot that. So submit an answer. So you have to do both. So whatever 2 points you're using, make sure you put those in. I'll do another one. All right, so again, we're going to start off with, notice how I'm starting all the way from the beginning. And if you remember, I said hit divide first. Parentheses minus parentheses over parentheses minus parentheses. All right, I'm going to come here. I'm going to set it up for my 2 points. All right, so I'm going to just start on the left. It doesn't matter. You start anywhere. Let me even start right here. Again, I'm looking for a corner. That's a corner right here. So this is a corner right here. This is the point 3 and then 6. You have to put x and then y. 3, then 6. All right, I'm going to keep going until I get to another corner right there. This is my second corner. So I'm going to do the rise right there and the run right there. So that part is already done. So the second point is 8 and 7. 8 and 7. All right, now back to my formula sheet. So remember, all I'm doing is matching, right? So we'll start with y2. So we're going to call this 1 and this 2. So start with y2. That's x, and this is y. I'm going to control X and Control V to paste. So that's y2. On the bottom, x2. So I'm going to take this one. On the bottom, Control X, Control V, x2, sorry. So that's my second point gone. Now I'm going to come to my first point. So my first point is y1. So this is a y value. Control X, Control V. And then x1 on the bottom, Control X, Control V. Again, you can see that it gets your decimal. Turn it into a fraction by clicking this. And you're going to get positive 1/5. So positive 1 divided by 5. I'm going to do one more just to make sure. Why not? Because I can. Let me try and do one that's on there, like something like that. All right, they're all the same question, to be honest. All right, so I'm going to leave this here because I need that. All right, set up my equation again, divide, right? Parentheses, minus parentheses, over parentheses, minus parentheses, and that's straight from the equation. All right, let's get my 2 points. So again, starting anywhere. So this is a point right here. So we can put this as a point. This is -7, so you do x first. -7, -10. So -7 and -10. All right, follow it until you get to another point. And it could be anywhere. This one right here. So this is my rise. And this is my run. So this point right here, x first, -3 and -7. So -3 and -7. Once I have my 2 points, right, I'm just putting it in the formula. So again, start off with y2. So this is going to be the first one. It's going to be the second. The second y is -7. Control X, Control V to paste it. All right, then x2, this is going to be my second x value. So Control X, Control V. Y1, so this is x, this is y, so this is the first y value. Control X, Control V, and x1, sorry, Control X and Control V. So there's my answer. Click fraction and then come and put it into your answer choice. So this is going to be 3 divided by 4. All right, so we'll take a look at finding slope from points. So again, we need the formula. All right, so one more time. Again, what's the formula? You're going to put it in here as divide first, and then parentheses minus parentheses over parentheses minus parentheses. So again, that represents these letters right here. So we just need to go find what's y2, what's x2, what's y1, what's x1. Put it in here, and it'll do it for you. So back to your question. Here are your 2 points. So I'm going to take these 2 points so you can see the formula at the same time. I'm just going to paste them right here. You don't need to do this part. I'm just doing it so you can see. There are my 2 points. Okay, so now I'm going to go to my formula. All right, these are my 2 points. This is my first one, and this is my second one. So the one I'm interested in right now is y2. So what's the second y value? So it goes x and then y, x and then y. So this is my second one. I'm going to do Control X, Control V, and then x2 on the bottom. So this is my second point for x, Control X, Control V, and then y1 on the top. So the y value, Control X, Control V, and then the x value, Control X, Control V. All right, it says undefined. So let me just double check my equation because I think I did something wrong. So -5, -5, -8, -5, 4. Well, actually, that's fine. There's undefined right here. So click undefined. It is undefined. All right, new problem. So again, same idea. I'm going to put in my slope formula first. So hit divide and then do parentheses minus parentheses over parentheses minus parentheses. All right, I'm going to copy my 2 points here just so I can know that I didn't make a mistake at any point. Control C, Control V. That didn't do it for whatever reason. So hit copy, paste. All right, right click if it doesn't work. Right click, copy, Control V, paste. Ooh, that was weird. All right, let's X out all these extras. Just make sure it copies the right thing. So yep, that's the right thing. Go back to my slope formulas just so I can make sure I see it. So again, this is my first one. This is my second one. This is X and this is Y. So starting off with my second Y. So this is my second Y. Control X, Control V. Then I need my second X. So this is my second one. This is X, Control V. Then I need my first Y. So my Y1. Control X, Control V. Then I need my first X, Control X, Control V. All right, again, this is another undefined question, and that's fine. I mean, it's fine. Whatever the answer is fine. If you get a fraction, just make it into a fraction. All right, we're going to move on to table to linear equation level 1. Table to linear equation. So it's very important that you know what a linear equation looks like. And again, this is right in your formula sheet. In fact, I'm actually going to Google your formula sheet. So Algebra 1. EOC formula sheet. Just so that we are actually talking about the exact same thing. So you have this, of course, when you're taking your tests. All right, perfect. So here's my formula sheet. So we are good to go. And I need to know, what was it I was looking for? So I was looking specifically for a linear function. Okay, so I'm going to come to my formula sheet and I'm going to look for a linear function. Okay, so something close, linear equation. So I got three options. Okay, so there's a slope-intercept form, point-slope form, and standard form. Okay, we're going to work on the slope-intercept form. So I'm going to copy this down, y equals mx plus b. Yes, which you already know, of course. So y equals mx plus b is what I'm going to copy down. Y equals mx plus b. This is what I need it to be, right? But they're giving me a table. So how do I figure that out? Well, you can put this table in this graphing calculator and then it'll figure it out for you. So I should have started with doing that, but let's do it now. All right, press the plus sign right here. Table. Now you see it's a table. Plug in these numbers. So 0, enter, 1, enter, 2, enter, 3, enter, 4. Come back here. -5, enter. -1, -1, enter. 3, enter. 7, enter. 11. All right, so here's the table, and you can see here's my linear function, right? So I just need to somehow get this line to connect. Well, to get that line to connect, you come back to this. And then what you're going to do, all you're going to do, you're going to change three things. For one, notice that this isn't an x. It's called x sub 1 or x subscript 1. So all you're going to do is come to the x and put a 1. See, it made it x subscript 1. You're going to go to, this is not y, it's y subscript 1. So you're going to come right here and put a 1. And sometimes be careful because sometimes it's 2. So be careful. Okay, so there is still an error, and this is the weird thing. I wish I didn't have to do this. It's this equal sign. You're going to change this equal sign to this squiggly line. And I'm sure there's a way, there's a word for it, but I never remember it. So click ABC, and I'm looking for this squiggly line right here. Squiggly line. As soon as you do that, see what it did? It plotted your linear function, right? So now you just go back and see what it is. You're going to write y equals, because it's an equation, mx plus b. And you're going to substitute your m for the m right here, which is 4, right? So your m is 4. And your b, which is -5. Now, to make sure that you are right, so that substitutes -5. To make sure that you are right, you're going to copy your answer, right? And we're going to do this. We are going to paste it right here with the y equals. Okay, I hate that it's the same blue line, so I'm going to do it again. I'm going to X out of that because I don't need it to be a blue line. If I did this right, it's going to go over this line. So Control V. See how the green line, so if I hide the line, you click right here. You see how it hides the color? See that? It's exactly right. So don't press enter until it's exactly right. Then you can click submit. That's how you cheat with this calculator. I'm sorry. That's how you use the tools available to you to do this work. All right, let's do another one just to be clear. So let me start off with the table. So again, I want to put this in the calculator, right? So you're going to press plus, and you want what? A table. Then you're just going to copy it down. So this goes 0, enter, 1, enter, 2, enter, 3, enter, 4. Then come back to 0. It's -5. Just make sure when you copy this down, you copy down exactly 4, enter, 13, enter, 22, enter, 31. Okay, so there is my table inside the calculator. All right, remember, you want a linear function, right? So again, a linear function. What happened to my formula sheet? I don't know what happened to it. It became smaller. All right, a linear function. Okay, I don't know what it's doing, but boom. A linear function needs to be y equals mx plus b. So as long as you know that and you put that in the calculator, then you're good. So it needs to be y equals mx plus b with numbers, right? So y equals, so that's what we're going to write, y equals mx plus b. Cool. Now that you have that, let's look at what the calculator is saying. It's calling x sub 1. So you're going to come right here and put 1. Sometimes be very careful that you look, because sometimes it's 2, so or 3. So make sure you're looking. All right, and then again, it's calling y what? Y sub 1. So make sure you put a 1. And the only thing you have to remember, which I wish you didn't have to remember, but you do, is you change the equal sign to a squiggly line, which again, there's a name for this. I don't know what it is. Change the equal sign to a squiggly line. Boom, you see it's graphed it for you. All right, so my answers are m is 9. So I come to where m is and I put 9. And I go to where b is and put -5. I don't stop there. No. I'm going to make sure that I'm right because you have this calculator. So you're going to put in y equals, right? Y equals the equation. And I'm going to hide the purple for a second. When I put the purple back on, it has to go exactly on it. If it goes exactly on it, I did this correctly and I am right. All right, great job, guys. All right, when we go on to level 2, I don't care what level you give me, I got this, okay? So again, put in your table. All right, now put in your values as you see them. So this is 1, enter, 2, enter, 3, enter, 4, enter. And then you got 0, enter, 1, enter, 2, enter, 3, enter. And you can see it's becoming a straight line. Cool. Again, what is a linear function? Okay, according to our formula sheet, okay, linear function, is, again, there's 3 options. Y equals mx plus b, right? So we're going to go with y equals, oh, look at this, they didn't put y equals. So you're probably getting this question wrong because you're not putting y equals. Y equals mx plus b, right? That's what our function is. So I'm going to take this function, put it in the calculator. All right, so there's a little error. What's my error? So you're trying to tell the calculator, hey, look at this table and give me this equation. So you have to look at what it's calling, what it's defining its parameters, right? So you have x sub 1 here. So this needs to be x sub 1. Add a 1. Y sub 1. So this needs to be y sub 1. Add a 1. And the only thing you need to remember is change the equal sign to a squiggly line. Click ABC. Squiggly line is on the bottom. And you're done. Immediately, it's telling you m is equal to 1. So you're going to put m is equal to 1, and that's an invisible 1, so we can just leave it like that. And b is -1, so make sure b is -1. Again, we're not going to trust our answer. We're going to come right here. We're going to paste it. If I get this purple line right over it, I know that I'm right. Is my black line over the purple line? It is. By clicking this, you can see that. Once you know you are correct, hit submit. All right, so it doesn't matter what it is. All right, then we're going to go back to writing equations of lines. You need to grab your formula sheet real quick for this one. To write an equation of a line, if you look at your formula sheet, because this says of the line, it's a linear function. If you look at your formula sheet, it says y equals mx plus b. All right, what is, so it will tell you that, but you'll have to know what each thing is. What is m stand for? It's the slope, which is rise over run. And what does the plus b stand for? The y-intercept. What does that mean? Where it crosses, oh, what are you doing? Where it crosses the y-axis. Okay, so have that written down somewhere, where it crosses the y-axis. Oh, it's going the wrong way. All right, so I'm going to look at that in order to write it down. So it crosses the y-axis at 2. And then you pick any 2 points. I'm going to go from this point right here to this point right here to see my rise and run. So I'm going to rise 1, 2, 3, 4, 5, 6. If I'm going up, it's positive, so it's going to be 6. So if you're going down, make sure you put negative. I went up 6, and then I went to the left 1. If I go left, it's negative, and if I go right, it's positive. So do whatever your graph is doing. Put this in the calculator, press math, enter, enter. You're going to get -6. And it crosses at 2. So this is my slope, and this is my y-intercept. And then all you have to do at that point is just put it into your answer. So y equals my slope, which was -6, x plus my y-intercept, which is 2. And again, another way to know that if your slope is positive or negative is from the left to the right. This is going down, so it's negative. If it was left to right going up, it would be positive. All right, so go ahead and just put in your equation, substitute in slope and the y-intercept, and then you can just go from there. Oh, did I get it wrong? I think I did. So y equals 1, 2, 3, 4, 5, 6, and 1. That's negative 6 plus 1 and 2. Okay. What's it doing? It's not doing anything. Writing an equation given a linear situation. So again, what do I need? I need my y equals mx plus b. So I need whatever my slope is, how something is changing, plus b is where I start from, like what is my initial. All right, so how it's changing, and then what is my initial. So again, it's y equals then mx plus b. And I'm just going to put in the numbers. So blah, 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 blah. The temperature increased. Increased means a positive or negative? Positive. All right. The temperature increased and the snow began to melt at a steady rate. Okay. So there's a depth of 10 inches of snow. So there's my first number. What is that? Is that how it's changing, or is that what it starts with? So it says there's a depth of 10 inches of snow in the lawn when the storm ended. All right. So that's my starting number. And I'm guessing it's going to melt. It's going to start melting at a rate of 2 inches per hour. So here's a hint. Whenever you see the word per, like every, those kind of words, that's your slope. That's how it's changing. So this one is melting. So if it's melting, is it increasing or decreasing? Is the snow getting less or is it getting more? Hopefully you said less. So negative 2. All right. So, and again, write the equation, read what it says in terms of t. So it's not going to be an x, it's going to be a t. All right, so again, my initial is my y-intercept. My slope is how it's changing. All right, graphing lines from equations. So again, we're doing this simply by doing this in a calculator. So you're going to do Control C. You're going to come over to your calculator, Control V. All right, it's going to look a little funky, so you might have to fix it. So go ahead and fix it. Make sure you copy the right thing. I need to put 1 divided by 3 here. All right, now I've double checked my equation, and then I'm going to press this home button, so hopefully it takes me where it is. And then I'm going to copy my points into here. So it looks like there's a point right there at 4. And I can zoom in if you want to where it goes up by 1. So you see there's a point there at 4. So I'm going to put a point there at 4. Then I need another point. So what I'm going to do, what I'm going to do is look for another corner. So a corner, all right, just to refresh your memory again, is if you look in the background, these are the grid, right here. This is the grid. A corner is where the purple line, so let me change the color, where the purple line goes through a corner, across. So right here is a corner, right here is a corner. Is this a corner? No, because if I had a line, it would be over here, right? So corner is where it goes through the cross, all right? So that's what we're looking for. So if I come down this way, I'm looking for a corner. I think there's one right here. Yes, there is. So see right here, it goes through that cross. All right, so right here, see there's that cross. All right, that's a corner. So it's at 3. And then what's this number up here? I'm just going to go up real quick. Oh, actually, I should be going down. I'm tripping. It's a 3, 3, 3. Looks like it. 3, 3. So I go to 3, 3. And I put a line there. Okay, so I'm just going to double check. Looks like there's a corner here at negative 3, 5. So I'm going to just kind of zoom out. Negative 3, 5, negative 3, 5. And there's a corner right there. So now I've double checked my answer. That is correct. So all you're doing is putting it in and transferring it over. All right, so the next one. Same thing with this, you're putting it in and transferring over. So again, to copy, Control C, and to paste it in, you're going to do Control V. Make sure it's pasted everything it needs to be. And then we're going to copy it. This says, drag the red, blue dots along the x-axis. So you see, okay, and the y-axis to graph. So you just drag it. So I'm going to go look at my y-axis and press the home button again. It looks like my y is at positive 10. So I'm going to take this blue button and put it to positive 10. And then my x is at, oh, it's a decimal. So with this one, you got to be kind of close. But of course, when I give you the test, I'll make sure it's a whole number. So it's negative 3.33. So if I come right here to negative 3, and then 0.33 is maybe around here, and I might get this wrong. somewhere roughly around there. But again, on the test, I'll make sure that this point is like at -5 or at -4 or something. Okay, so this one's -3.33, which is around there. So let's see how sensitive it is. Okay, so it's not that sensitive. But again, I'll make sure that on the test it's a whole number. All right, so copying and pasting. All right, so we're going to take a look at how to use the Desmos calculator for pretty much all your work. So we'll start with the first one. This is how to use Desmos on 3-step linear equations. All you're going to do is copy, which is Control-C, the equation, the left-hand side, and then Control-V to paste it. So Control-C, then come to a new line, Control-V. Notice you might have an extra box that you need to get rid of, so you can do that. The intersection of those 2 points, because these two have to be equal to each other, right? So the intersection of these two equations is going to be your answer. Your x value is going to be your answer. All you have to do is click into one of these, and you can see a dot will appear, which gives you your x value of +1. So x is equal to +1. All right, now the key thing about this is there has to be an x on both sides. If there isn't, what you want to do is, of course, solve the equation to where you can put one x on that side and another x on that side. All right, so same thing with this. It doesn't matter what it is. If you have an equal sign, all I need, and again, I just said this, right? I need an x on both sides. So again, you're going to take Control-C, highlight it, come here, Control-V, get rid of the extra boxes that it copies into there. Then Control-C again on the right-hand side, Control-V. Now again, remember, because there isn't an x on both sides, that's why there isn't a solution happening. So I need to make an x on both sides. But notice that I have a -3x here, right? So we can move that -3x to the other side, and it's going to become what? +3x. So I can put a +3x over here, and then take away this -1 that I moved. And look at that. Something has appeared, right? So let's see what we're dealing with really quickly. If I press this home button right here, it will kind of zoom in, but it didn't help me. I'm trying to follow the intersection, and there we go. So I might have to move the line. Again, click in either one of these, the dot appears. So x is equal to -4. So x is equal to -4. All right, so solving equations, oh, it's telling me just to type the -4 in there. Solving equations is simple. Left-hand side equals the right-hand side. All right, question transforming formulas. This is probably the only question you cannot cheat on. Okay, so the only questions that you cannot use the calculator is this one. And actually, it's a very important concept that you are going to use over and over through your math career. So this one, you actually have to do a little bit of work, and I'll show you how to do that anyway. But this is the only question on this whole test that you cannot use this calculator to check. All right, so the formula has a density object of D is equal to M, and make sure you're using capitals and little letters, so M over V, okay? Where M is the mass, V is the volume. Solve the formula for V, so I need to make V the subject right here. So I need this equals something. So right now, that means I need to get rid of divide by V. What do I do? If I'm trying to get rid of divide by V, I can multiply by V. So multiply by capital V. When I multiply, this crosses out. So now I have VD is equal to M. So it's looking better, but do I have V by myself yet? No, I don't. So what's bothering that V is the D, right? And what is the operation between V and D? It's multiplication. So how do I get rid of it? By dividing. If I divide both sides by what I'm trying to get rid of, which is D, what's going to happen? This crosses out. I'm going to have V is equal to M over D. Did I get rid of everything except V? Yup, I sure did. And now I can put in my answer. So V is equal to M over D. So I'm just going to come right here. M divided by D. And I'm going to do a couple of examples on this one, because this one is probably the one that's going to take you, a little bit to understand. All right, so let's do another question. So it doesn't matter what the formula is. Just keep in mind, what are you trying to get rid of? And then what is the operation that you're trying to use? So in this question, I'm trying to get L in terms of everything else. So I need this one right here by itself. All right, right now that is not by itself. So we're going to start, I'm just going to move left to right, honestly. I'm going to start right here. How do I get rid of this so I can just have this left? Well, what's the operation between these two? Multiplication, right? I'm just going to copy the question down real fast. L over G. All right, so if I have multiplication, how do I get rid of multiplication? By division, right? So if I divide both sides by 2 pi, right? What's going to happen? This is going to cross out with that, which is okay. That's what I'm looking for. So now this is what I have. 2 pi over there, so t over 2 pi. And then I have the square root of L over G. So again, keep in mind what you are trying to do. So I'm trying to get this by itself. So I still have things that are bothering it, right? So we're going to use get rid of the square root next. And if you, get rid of the square root. And how do I get rid of the square root? The opposite of square root is squared. So we're going to do square both sides. So what that's going to do is going to cross that out and the square root out. That's going to leave t over 2 pi squared equals L over G. So I'm getting closer, but I'm still not there. Again, what am I trying to get by itself? L. So how do I get rid of divide by G? What's the opposite of divide by G? Multiply by G. Multiply by G on both sides. This crosses out with that, leaving L equals G times t over 2 pi squared. And now I have L by itself, which is what I was looking for. You're just going to type that in exactly how you have it. G, parentheses. Then I have capital T. Make sure you're using capitals and lower cases where you need. 2 pi, so 2 pi. And then the squared outside, which is shift 6 squared, or you can click this keypad. All right, so again, remember, what is it that's bothering it? How do I get rid of it? By doing the opposite. So that's the only one that you can't use the calculator for. So we're back to calculator. Solve this inequality and graph the solution. Okay, cool. Let's do it. So we're going to copy, Control C, paste it in our calculator, Control V. Oh, that did not do it. So try copy, right click, and that still not do it. So I guess it's having me type it up, which is fine. So go ahead and type in. Just make sure your question looks exactly when you're typing it in or copying, make sure that it matches, okay? Because that's going to be your major problem. All right, so solve. Now, remember, when we finish this, right, it's going to be x. When you're solving this question, it's going to be x is less than or equal to, or greater than or equal to, or just less than or greater than, right? So what that means is you're really looking at where it crosses your x-axis. So I'm going to hide this for a second. So I'm going to click hide. I'm looking for a green line. I'm going to zoom out. Boom, there is my green line there. So what's my solution? Right here, where x is on the left of what? -7. Now, is it an open or closed line? It's open, which means that my solution should also be open. So x is left open of -7. Okay, now we can double check this because I'm going to take my answer, right, and see if I put it in here. So now that I can see my graph, whatever color this is going to match. Yes, it does. So this answer, how I've typed it, is correct. Let's say I typed this by mistake. Let's say I thought it was this. Look at that. No, that would not be it, right? So again, check your answer. So put it in and check it. Now we just got to transfer it here. So what do we transfer? -7. So -7 is right here. I think you're supposed to put a, okay, excuse me. How do I undo that? Okay, I'm just trying to delete. Maybe here. All right, hold on. Click line to delete. I'm trying to just delete. I'm gonna pause and do that. Hang on. All right, so I actually ended up clicking this to delete. Okay, so whatever it is, click that. That deletes it. Okay, so I want -7. All right, and then I want it to go on the left side. Do I want it to stop? No, so make sure you go to the arrow. Oh, delete. So you got to drag it. So -7 to the arrow. Okay, now, is this open or is it closed? Open, right? So I need this to be open. So you do need to know a little bit on how to put your answer in, open or closed, and that's really all. The calculator can do the rest for you. All right, let's do another question. Let's do one with an equal sign. There we go. And actually, let me make one negative. Equal. There we go. Boom. All right, so again, okay, take your question, copy, Control C, paste it, Control V. If it looks weird, just fix it. That's all you got to do. So I need a negative, Control X, Control V, and I need a 33, Control X, Control V. Make sure it matches up, right? Oh, no, it doesn't. See, that's why I said be careful, right? Always check. So that's a negative. So we'll put a negative there. All right, now that that's done, look, you have an answer. All right, so I need to be to the right of 4, right? Because it's X in the question. So to the right of 4. So I think it's X to the right or equal to, and I have to match the sign, right or equal to of 4. That's what I think the answer is. So I'm going to take this answer, Control C, Control V, put it in my answer, and then I'm going to really pay attention to this, all right? So I don't like black, so I'm going to Control C that one and find another color. So, oh, not red. I definitely don't want red. Let's cancel that one too. Blue is fine. Okay, cool. I'm going to hide this one real quick. All right, now look at it. Does this overlap exactly? Yes, it does. Okay. All right, so the thing you have to be mindful of, if it has an equal sign underneath, make sure you do that, because if you don't, oh, actually, this is perfect. You can tell the difference, right? Look. So if I didn't put the equal sign, I was checking my answer. You see that? You can see some red spaces. You shouldn't see any spaces. So you would know, oh, okay, that's because I was supposed to use this one, because now it's perfect, right? There's no spaces. Everything is perfect. All right, that's actually great. I love that. All right, now let's go ahead and graph it. So you start at 4 and you're going to the right, all the way to the right. And then is it open or closed? It is closed. And so you are done. All right, moving to graphing linear inequalities. As always, Control C and Control V. Boom, it has graphed you for it. Now, your only thing that you're responsible, make sure it matches, it does. The only thing you're responsible for is moving this graph here. And this, for whatever reason, is something that people struggle with. You have to find corners. So what you do is, first of all, stay within, this graph goes from -10 to +10. So you should not be looking over here. Stay within -10 to +10. What you want to do is you want to move, you want to click with your mouse, and you want to move until you see these numbers be perfect. Like you see, that's 0, but that's not 8.7. -8.75 is not perfect, right? So keep moving until you find something perfect. Boom, there's one that's perfect. -5 and 3. So I'm going to go to -5 and +3. Okay, so -5 and +3. So boom. And I want to keep moving until I find another perfect number. Keep moving until you find another perfect number. Oop, there's a perfect number, 0, 7, 0, 7. All right, that's how you graph it. So look at it, it's on the top left. Yep, that looks right. Okay, the only thing that doesn't look right is why isn't this line dotted? Oh, because I gotta do it. Let's change the line to make it dotted. Okay, cool. All right, I also need green over here. How do I do that? Change the shade. Oh, there we go. Submit, and we're done. Okay, so again, this calculator can do everything for you. Control C. All right, gonna press this right here to bring it back. Delete that. Control V. It looks weird. Make it look like what it should, which this is right. So I'm just gonna X out of everything over up here. All this weird stuff on the top. All right, it's giving me an error for some reason. Oh, I guess it needed a second. Okay, there. So I need to transfer this here, right? So again, remember your window is -10 to +10. So we're going to hide this because I don't care about that anymore. I'm only looking at -10 to +10. So start your graph, click on your mouse, and you're looking for perfect numbers. So you keep going until, ooh, there's a perfect number, -8, -2, -8, -2. And then keep doing it until you find another perfect number. There you go, -4, 0, -4, 0, bam. Open or closed, because you have to make it look exactly. It's open, change the line. And then where do I shade it? Make sure it's shaded over here. Boom, done, simple, cake. Okay, so all you gotta do is put it in the calculator, match it in here. So we're gonna look at linear inequality systems graphically. It's just like the last question, so I'm not gonna go into too much detail, but if you don't understand this, just go to the last question and I go into more detail then. All the differences is that you're doing, instead of one equation, you're now doing 2 equations. So Control C, Control V, get rid of all this extra stuff that they put in there. Make sure it matches. Yes, it does. All right, then Control C again, Control V. Again, make sure it matches. So this looks a bit weird, so I should have a fraction. So we're going to do this, x out there. I need to put -1 divided by 3, x plus 7. So I can take this one, Control X, Control V. Make sure it matches, boom. And I don't like black, so I'm actually just going to do Control X, Control V to change the color, okay? I don't know why it's not picking up this one, so I'm going to do, oh, there it is. Sometimes it takes a second. All right, so I have got both of these here, right? Now I'm going to transfer both of these here. So I'm going to start off with the first one. So I'm going to hide the second one. See how hiding it? So I just don't get confused. The only window I'm interested in is -10 to +10. So I'm going to press this to hide it. And I'm only looking from -10 to +10. I'm going to start at -10. I'm going to hold my mouse down and I'm looking for perfect numbers. So there's one, -9, -10. So I'm going to go to -9, -10 and put a dot. Okay, now this is preventing me from putting a dot. So I'm just going to go look for another one. It's okay. You just keep going. All right, so keep going, keep going, keep going. There's one, -7, -8, -7, -8. And this is great because it shows you it doesn't matter what the numbers are. Once you get two numbers, it makes a point. All right, keep going. There's another one, -4, -5, -4, -5. There are my 2 points. Now look at that line, look at this line. What do you see? This is dotted, so let's change that to become dotted. What do you see right here? This is shaded here, right? So let's change the shade. Do I want it shaded there? No, because that's not what it is here. Change the shade. Boom, that's shaded. That's the first line inputted. Now we're going to draw the second line, right? So now I'm going to come back here to my equation. I'm going to hide that one and put this one on. So this one's on. Then I'm going to hide that. And again, the same process. Starting at -10, I'm going to go until I get my perfect numbers. And maybe you can't go fast. I don't know. Maybe you have to go slow. Oh, I think I passed one right there. Okay, it's okay if there it is. All right, -6, 9. So maybe don't go too fast. Slow it down if you can't find. -6 and 9. And then keep going. So maybe don't go fast, like, just kind of slow it down a little bit. All right, so, and if one point is giving you like a hard time, that's okay. You can skip it and go to the next one. So if you just do it slowly, you should get there. So 6, 5 is what I'm putting on there. So 6, 5. All right, then what can you tell me about this line? Does it look like this? No, so let's change the line. Okay, cool. And then the shade needs to be where? Over here, right? So make sure the shade is over here. Boom, like that. Now what's interesting is apparently at 6, 5, it crosses this other one. Let's go check to make sure that I got this right. So put the other one back on. Does it cross at 6, 5? It does. All right, now let's hide this real quick and let's look at my shading. Okay, the colors are going to be different, but everywhere is shaded except this little top part. Is that right? Yes, it is. So I know that I'm good. Now, you have to find your solution. So this is the only part the calculator cannot do for you because you have to understand what is a solution. A solution is where both colors intersect. So I'm going to hide the colors again. Okay, I'm going to put the color on. Boom. So where you see green intersect with purple, which is down here. Stay away from dotted lines. You're good with solid, but not dotted. Stay away from here. So pick anything inside here. So anything inside here. Anything at all. Any point at all. Any point you want. Stay away from dotted lines because it's not equal. So let me put the point 6, 1. Okay, so I didn't realize I got cut off in the last video. So I already answered a lot of questions, but I'm going to come back. So once again, I think we were on defining the variables x and y. If you get the one that has the x plus y equals, whatever number, go to that number and see what it's talking about. So right now it's saying, where's 10 right here? So 10 is the total of what? Of cupcakes and brownies together, right? So you got to think about what that's talking about. If it's the total of cupcakes and brownies, it's not going to be the price of a brownie. It's not going to be the price of a cupcake. It's going to be the total number. So it's the number of cupcakes and the number of brownies. So just go to this equation, the one that looks like this, and ask yourself, what does this 10 represent? And then decide what x and y is. Okay. All right. So after that one, again, all right, we'll take a look at write single inequality from context. Okay, this, obviously, I can't put this in the calculator. It's not going to do it for me. I have to read it, yeah. So, Tuab, I don't know, however you say this name, is working 2 summer jobs making $11 per hour lifeguarding. So it's $11 with L, lifeguard. All right, and $7 with washing cars. So I don't know if I'm adding or subtracting this right now, so I'm just going to put a space and do $7. Oh, it wasn't letting me space. $7 washing cars. Okay, so 11 lifeguarding, 7 washing cars. All right, he must earn a minimum. Okay, so this is, you have to understand what the words mean. Okay, what does minimum mean? All right, of 140. He has to earn 140. Can he earn 139? No, because it says a minimum of 140. So when I add this two together, right, for my 2 jobs, I have to make at least 140, which means anything more, like 140, 141, 142, 143. So my options are going to be between these two because I can make 140, but I have to make more. So I click that, and then I put 140. Okay, so with this is just finding some keywords and then seeing what they mathematically mean. So again, with this, because there's no calculator, I'm going to do a couple of them to make sure. So drama club is selling tickets to play that raise money or show expenses. Each student ticket sells for $4.50. Okay, so student is $4.50. So $4.50 student. Notice I always start writing even before I finish the question. Adult tickets are $8.50. So I'm guessing I'm going to get the sale. So I'm going to add this. So $8.50 for adults. A for adults, S for students. Okay. So when I sell these tickets, what happens? The drama club must make no less. So what does no less mean? I can't make anything under, right? $6.50. So can I make, so the question becomes, can I make $6.50? I can. Can I make $6.49? No. All right, can I make $6.51? Yes. So I can make $6.50 and above. So $6.50 and above, greater than or equal to. Equal to because I can make $6.50. Greater than because it has to be above $6.50. All right, so that was kind of the same question. Hopefully this one is a different one. No less is the same. Let me do another one. Where is it? No more. Okay, this one's different. No more. Yeah, this one's different. All right. So Catherine is working 2 summer jobs, lifeguarding and walking dogs. So here you go, lifeguarding, walking jobs. She can work no more. Okay, so what is no more? Okay, it means that's my maximum, right? Then 14 hours. So I can work 13 hours. 12 hours. I can even work 14 hours, but I cannot work 15. So it has to be under or equal to 14 hours. So whatever I'm doing, under or equal to 14 hours. All right, write an inequality that will represent, write an inequality to represent the possible values for the number of hours lifeguarding. So the number of hours lifeguarding plus L and the number of hours D. All right, so the number of hours dog walking. So when I work both of these hours, it can be no more than 14. All right, so this you do have to identify what it's saying. So this would be the second question so far that you cannot use a calculator on. All right, so we're going to take a look at simplifying algebraic cube roots. So how do I do that? Again, it starts by breaking everything down. So let's break down 125. And again, you can just do this in a calculator. So this is how many 25 cents in $1.25? There are 5 of them. And then how many 5s in 25? It's 5 as well. So it breaks down to 5 times 5 times 5. And you can simply check that with a calculator as we've previously done. So I'm saying 5 times 5 times 5 is equal to 125, which is true. Okay. Break down x to the 8th power. So I'm going to actually write this all out. So I have x squared, y cubed, and I'm going to leave a lot of space. And I'm going to write out what I have. So this is cube root, right? Which means how many cards make a book? 3 of them. Then breaking this 125, this is 5 times 5 times 5. X to the 8th power, what does that mean? X times x 8 times. So that's 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then what does this mean? Y 10 times, right? Y 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so once you have everything broken out, so it's time for us to make books. How many cards make a book? All right, so again, this number right here tells you how many cards, the index. So that's 3 cards make 1 book. So every 3 cards makes 1 book. So I'm putting times 5 outside because that's 3 cards. Do I have a book of X's? I do. These 3 make 1 book. All right, these 3 right here make another book. These 3, oh, there's not 3, there's 2 left, right? So does that make a book? No, because I need 3 of them to make a book. So I'm going to go to the Y's. 3 make 1 book. 3 make 1 book. 3 make 1 book. All right, once you have all of that done, now you're just combining what's left. So outside I have 5 x. How many x's do I have? So this is 2 x's, right? 3, 4. So a total of 4, right? Because x squared, remember, is x times x squared. So I have 1, 2, 3, 4. How many y's do I have? So I have the 3 that are right here, 4, 5, 6. All right, now what do I have left inside? I've got 2 x's. How do I write that? 2 x's. And I have 1 y. How do I write that? Just like that. All right, then you go ahead and put in your answer. So that's going to be 5x to the 4th power. So shift 6, or you can press the keyboard right here. To the 4th power, come out of that. Y to the 6th power, shift 6, or you can press the keyboard. Then we have cube root, so we're going to put the cube root one. And what do I have left inside? I have x squared, so x shift 6, or you can press the keyboard, and 1y. All right, so, okay, and I just did that just to show you that I make mistakes as well. Just be very careful. You see this cube root, right? It's over the whole thing. It's supposed to be x squared and y over the cube roots. And I forgot to put a cube root right here. All right, so this is cube root. And notice what I put in the answer. This did not extend all the way out. I clicked out by mistake. So just make sure that it is cube root over all of it. So it's like this, not like that. Okay, but this is the exact same answer. And that's how you factor out perfect cubes. We'll do one more example just because I got that one wrong. So let's do another one. So here it is. Express that as the simplest in radical form. So we're going to go ahead and show our work for that. All right, so again, start by breaking everything down. So let's break 27 down. That's 3 times 9, and you can just use a calculator. And this is 3 times 3. All right, so you have 6, leave some space. Then what do I have? 3, 3, 3. How many x's do I have? 4. 1, 2, 3, 4. How many y's do I have? 3. 1, 2, 3. All right, so again, how many cards make a book? Because this says cube, and I guess I should put that in there. Because it's cubed, it's 3 cards make 1 book. So 3 cards make 1 book. 3 cards make 1 book. 3 cards make 1 book. Nothing else I can take out, right? So let's combine the outside. 6 times 3 is 18. I only have 1 x. I only have 1 y. And then cube root of what's left inside, just 1 x. So again, just make sure that when you're typing in your answer, you're typing in exactly what you have on your paper. On this one, you got to be very careful. So x, y, cube root, and then x. Just double check that this matches what you wanted, which it does. And that's it. All right, simplifying radicals. I love doing books, y'all. Okay, so let me find numbers that are really big. And again, we can't get the answer from the calculator, but we can check our answer with the calculator. Okay, so let's do this one. So we're going to start off by putting the answer in here. So square root of 125. Let's see if it'll let me copy, paste. Okay, so it's making me put it in. So you have to put square root. So come right here and press square root. And it's got to be inside there, so 125. So get rid of that. So this is my answer. Whatever answer I get, I'm going to put it here. And it should be 11.180, blah, blah, blah. But I do have to do this by hand, unfortunately. But I can use a calculator to check my answer. All right, so by hand, I'm going to do it by hand and then check my answer. All right, so we're going to start off by breaking it down. But again, all of this part can be done with the calculator. Let's break down 125. All right, so we're going to check. So you check divide, right? All right, divide. We're going to check. We're going to start. Remember, it's 2, 3, 5, 7, 9. So 2. Why isn't it doing it? Sometimes it takes a second. I don't know what it's like. If it's thinking or something. If it takes too long, I do it again. So let me do it again. Do I have to press enter? I don't know what this is doing. Why is this error? Is it a division problem you don't understand? Okay, hold on. Let's do it. Let's do this again. So 125 divided by 2. Okay, I don't know. Sometimes you have to retype it. All right, that's a fraction, so 2 is not going to work, so I'm going to check 3. 3 is not working. 4, I would say 5. All right, 5 works. So this breaks down to 5 times 25. All right, so this is already there. So let's break down this down. So I got 25. What does 25 break down to? Oh, and look, it already did that. But again, you would check 2, then 3, then 5, right? So it breaks down to 5. And these are all prime numbers. I can check to make sure that this is right. So if I did 5 times 5 times 5, do I get 125? Yes. So this whole part is right. All right, so this is my books right now. So watch this. I I'm going to keep this up here actually, but I'm going to check what I just wrote. So remember, anytime I do something, 5 times 5 times 5. Anytime I do something, right, I'm going to make sure that this number stays the same. See how they're the same? So I'm good. All right, now let's take out books. So we're going to take out this book. All right, so 2 cards make 1 book outside, right? So I'm going to delete those. Oops. Delete that and put 1 book outside, because see, the number has changed. But if I put my 1 book outside, look, my number is back. Are there any other books I can take out? No. Is there anything else to combine? No. So this is my final answer. So I'm going to come back to Delta Math, and it's changed my question, and that's fine, but that would be your answer right here. Okay, so I actually can figure this out without writing it down. So let's do 162. Okay, so we're taking 162 here. 162 divided, oh, actually we can't do it there. We got to leave that out there. 162, you got to do your prime factorizations outside. Divided by 2, that works. So you get 81. So look, 2 times 81. See, that still gives me that same answer, right? So keep breaking 81 down. So now we're on 81. So I'm going to change this number here to 81. Break that down. 2 doesn't work. Check 3. 3 times 27. So instead of 81, I'm going to get 3 times, see the number changed because I need that 27 back. Okay, cool. Number is back to being the same. All right, break down 27. So we're going to go to 27. All right, 3 and 9. So we're going to break out 27. 3 times 9. All right, see how the number is still the same? Break down 9. 3 and 3. Okay, so 9 becomes 3 and 3. 3. And again, see how the numbers change? But when I put the next 3, we're back in business, right? So look, this still matching, right? Now I'm going to take our books. So remember, every 2, so I'm going to delete the 2, become 1, right? So when I delete that, see the numbers change? But because I need to put the 1 book outside, number is back. All right, any more books? Yep, I see these right here. So these 3. So again, when I delete that, see how the numbers change? Put it where? Outside. So this is times 3, right? So those are my books outside. My numbers are fine. Any other books? No. So my last step is to combine these 2, because I can't put this in as an answer. So 3 times 3, again, you can put that there, is 9. So you're going to cross this out and put 9. My numbers are still matching. No more books to take out. This is my final answer. Yay. All right, so let's do, is that one where it gives you a number outside? Nope. Okay, I'll just do one more just for the sake of it. Let me get a number that's big. I like doing bigger numbers. All right, like 112. All right, so let's put 112 here. All right, and this is going to be our breakdown. So we're looking for it to stay at 10.5, whatever, right? So we're going to put 112 divided by, all right, we'll check 2. All right, 56. So it's going to be 2 times, is that a fast way to say times? Yeah, 2 times 56. All right, we're still at the same number, so we're looking good. We're going to break down 56. 28, 2 times 28, so come right here. It's going to be 2 times, and you see how the number has changed, so we got to do 2 times 28. Again, matching my numbers, I'm good so far. All right, going to break down 28. That's 2 times 14, so again, keep an eye on that number, 2 times 14. My number is still good. Break down 14. All right, that's 2 times 7. So 2 times 7. My number is still good. Can I break down 7? 7 doesn't break down anymore, so I'm good. All right, so my numbers are still matching. Let me take our books. These are going to become 1 book, right? So that deletes. Number is different, but that's because I got to put my book outside. So I'm okay so far. It's coming back. All right, this is going to make another book. Well, number is different, but that's okay because I just got to put my book outside, right? So times 2. Oops. All right, so my number is back. I can't put this in the answer. I got to combine this. So what's this going to become? 4. So this is going to be 4. And I'm still matching, so this is great. So this is my final answer. Okay, so that's how you do it with a calculator. You're just checking it with a calculator the whole time you're doing the question. All right, let's take a look at sum and product of irrational numbers. All right, so again, what does sum mean? You're adding. So I'm going to take these and put them in the calculator because, hey, why not? Let's see what it'll let me copy. So let's copy that. Ooh, okay, that looks all weird. All right, so I guess I gotta have to type it in. All right, so radical 9 and sum means plus 2 radical 25. So when I finish this answer, oh, look at this. The answer is 13. Put in 13. All right. The result is rational. Why? Because it's 13, right? Because it can be written as a ratio of numbers, and its decimal expansion does terminate or repeat. So we ended up getting an easy one. So all the rational ones will give you an actual number. The ones that are irrational, so let's see if this one is 3, and this is sum again. So sum is still addition, and 2 radical 2. Let's see. All right, see, this is not rational. So I already can tell you the result is irrational because it cannot be written as a ratio. It does not terminate. But we have to know what that answer is, right? So that's what we're working out. So can I break anything down over here? No. Can I break this down? No. All right, so can I combine the terms alike? Is radical 2 the same as radical 5? No. So actually, there's no work for me to do here. This is just the answer. All right, next we're just going to look at some vocab. And again, with this vocab, you just have to know what it is. So I'm actually just going to show you what vocab means. All right, so the number of terms that a polynomial has is how many things do you have between the minus and plus. So you see, this is one thing, and then this is the second thing. So it has 2 terms because there are 2 between the minus. The constant term is the number without any variables. So it's the number by itself with no variables, so which is -1/7. The lead-in term is the one that's first after you put it in order. So you do have to put it in order, like, this is -2x minus 1/7. So really anything in order means like, x to the 5, then what? X to the 4, then x to the 3, then x to the second power, then an x, and then the coefficient term, right? So that's what it means in order. In order 5, 4, 3, 2, 1, 0. So whatever the lead-in term is, the very largest term, so this one in this case in my example will be 5. But in this one, the largest term, right, is this, because if you put this in order, the constant has to be last. So the constant term, so lead-in term is -2x, the whole thing, -2x. So that's the basic definition. Now we're just going to go through a whole bunch. So again, the very first thing you have to do is put this in order, right? So it has to go 5, 4, 3, 2, 1, nothing. So in order here, what's the highest? 5, right? So this is x to the, and let me just do a new page so it doesn't confuse you. All right, so this one in order is x to the 5th power, and it's positive. Then what's next? This one's gone x to the 4th power, so this is plus, don't forget the symbol, x to the 4th power. So I've used 5, 4, what's next? 2 will be next because it skipped 3. So again, make sure you put the symbol for it, so squared. Then 1, because it's invisible, 1 minus 8x. Then the constant, so remember the constant is by itself. So you have to write it out with the symbol. So this right here is a positive, so that will be positive right there. So once you put it in order, you can answer any questions. All right, so this expression represents what kind of polynomial. So these are the different definitions, and again, you have this in your notebook. Cubic is 3, quintic is 5, quadratic is second, quartic, like think how much is a quart, is 4, and linear is invisible 1. All right, so in this case, right, so you just look at the lead-in term. So the lead-in term, remember, after you put it in order, the very first on the highest degree, that's what represents your polynomial. So the highest degree is 5, so you go to the one that means 5, so quintic. So again, in order, it goes linear, invisible 1, quadratic 2, cubic 3, quart, like how many quarts? 4, then quintic 5. So in this case, I want quintic. How many terms does it have? So how many of these between each equal sign? This is 1, 2, between each addition and subtraction. So 1, 2, 3, 4, 5. There are 5 different terms. The constant term, okay, that's the one without the x. It's the one at the end, after you put it in order, is +1/7. The lead-in term, so that's the very first one, the whole thing. This lead-in term is x to the 5th power. And the lead-in coefficient, so again, from the lead-in term, what is that number? That's what that means. From the lead-in term, what is this number right here? It's an invisible 1. All right, so again, we'll do another one just in case you didn't get it. First, you got to just put it in order. I'm just going to kind of click through and see if there's anything hard. And there isn't. Okay, so it doesn't matter. I'll just pick one. All right, so we have this. The expression represents, this is already in order, right? Because it goes 2 and then here there's nothing. So it's already in order. What kind of polynomial is it? If it's to the second power, it's quadratic. That's just by knowing your definitions. How many terms does it have between each plus and minus? There are 2 terms. The constant term is, that's the one without the x, is -1. Make sure you don't forget that negative. The lead-in term, so the one that's first, after you put it in order, this one's already in order, is x squared. So x shifts 6, 2. The leading coefficient, so that means you look at the lead-in term, then you look at the number of that term, is an invisible 1. All right, I'll do one more because that one is, I think, a bit easier. You didn't have to rewrite anything. The one that looks complicated. All right, here we go. Boom, a whole bunch of stuff. All right, again, put it in order. So what's the highest degree or power? X to the 4th power. So this is x to the 4th power. What's next after 4? It'll go 2, 1, nothing, right? So it'll be this one. So we're going to write it out. 1/3 x squared, 2. Then invisible 1. So this is -x. Make sure you don't forget the symbol, -x. And then the constant without the variable is -3. And once you have it in order, then you can answer the question really easy. This expression represents what kind of polynomial is it? So you look at the highest degree. Is it cubic, 3, quintic, 5, linear invisible, 1, quartic, sorry, I might say that wrong, which is 4, or quadratic, which is 2. It's 4. So this lead-in term tells you the polynomial, which is 4. How many terms does it have? So there's 1, 2, 3, 4. So how many between the plus and minuses? The constant term, the number without an x, is what? -3. So make sure you put -3. All right, the lead-in term, that's the very first term, is x to the 4th power. All right, and the lead-in coefficient, so you look at the lead-in term. What's the number in front of the lead-in term? Invisible 1. So in this case, it's also 1, but if there's something else, definitely put something else. All right, take a look at adding and subtracting polynomials. So I'll do one that's subtraction because that's the one that trips you guys up. This one isn't really a problem with adding, so I'm going to do a subtraction. As a matter of fact, I'll do it in words. All right, this is subtraction, but I'll do it in words. All right, perfect. Here we go. So subtract 9x squared plus 4x from the other term. So remember, if you're walking to the cafeteria from my classroom, where did you start? My classroom. So even though I said my classroom the second time, that word from means that it goes first. So again, if I walk to the cafeteria from class, where do I start? I started at class, so I put class first. So this is -4x squared minus 7. And what does the word subtract mean? Minus. And then the cafeteria, 9x squared plus 4x. All right, once you have that written out, you're going to go ahead and just distribute anything that's outside. There's nothing outside here, so this is just -4x squared minus 7. But right here, there's an invisible -1. So we're going to multiply that in, distribute it in. That's going to be negative times a positive, which is negative, 9x squared. And a negative times a positive is negative, so that's going to be -4x. Once you have distributed everything you're going to go ahead and combine like terms. So what looks alike? I have x squared, which terms are alike terms. So those two terms look alike, so we're going to combine that. I have negatives and made in negatives, and again, feel free to use a calculator. I'm just going to do this by hand. It's going to be more negatives. How many negatives in total? 13x squared. Do I have any other like terms? I do. I have the constants, right? Which, oh, sorry, I don't have constants, actually. My bad. I only have one. I'll put this in order as well. So it's going to be -4x. There's nothing else to combine that with, so it's just going to be -4x. And then also by itself with nothing else to combine is this -7. All right, so -7, and that's it. So we are done. So that was a nice easy one. So 13, sorry, negative, make sure you're writing what you have done. 13x squared minus 4x minus 7. Always double check to make sure you wrote down what you have on your sheet of paper, and in this case I did. So I am done. All right, so let's do another question. So this time, instead of the word from, they just give it to you. So let's go ahead and write it down. Then once again, all right, is there anything outside here? No, so this is just going to be the same thing. This negative, we're going to distribute it in. Don't forget to say hi to everyone. Negative times a negative is a positive happy face. So 6x squared. Let's distribute it to the next person. I have a negative times a positive. What's that? Unhappy, so sad face, negative 5x. And then I have a negative times a positive again, which is a sad face. All right, so once you've distributed it to all three, make sure you get it to all three, you're ready to combine like terms. So let's combine like terms. So what looks like alike? Let's start with the highest degree. We've got squared. So that term is the same as that term. Don't forget the symbol. So what is negatives are made in positives? They're going to fight or join. And you can put that right in a calculator, negative 1 plus 6. They're going to fight. And who's going to win? These guys are going to win because they have more people by 5. So this is 5x squared. So I've done those terms. What's the next highest term? So the next term is the ones just with the x's. So that one and that one. Negatives are made in negatives. What's going to happen? Join and become more negative. So negative 10x. And again, you can just put in the calculator negative 5 minus 5. So that's gone. The only thing left is this negative 6. All right. So again, once you have it written down, just be very careful as to what you're typing to make sure you match in exactly what's on your piece of paper. And once you're sure it's matched, you can go ahead and submit it. Great job. All right, so we're going to take a look at factor to standard form. Another way of saying this is multiplying polynomials. Okay, so either question they can ask you, it's the exact same thing. All right, remember standard form is getting it to where it's in the version of ax squared plus bx plus c. All right, and you do that by multiplying polynomials. So we're going to multiply these two polynomials. You can do this with a box method or distributive property. It's going to be your choice. I think I'll do box method just for organization. I'm going to start off with the parentheses. So on the outside, I have x minus 8. On the top, I have x minus 4. So this, I'm just doing this part first, and then I'm going to multiply the answer I get by 2. Okay, so just doing the two polynomials together, x times x is x squared. Negative 8 times x is negative 8x. X times negative 4 is negative 4x. Negative 8 times negative 4, so that's a positive 32. All right, then remember, once you've multiplied everything, you combine like terms. The only terms that are going to be alike if you organize it in order is going to be the diagonals. So you see these x's are the only ones that are alike. So x squared, I can't combine with anything else, so that's just x squared. And remember, this is all by 2, right? So this times this is what I'm about to write the answer to, but this is 2 outside. So I have x squared, combine these like terms, negatives are made in more negatives, that's going to be 12x, still negative, and then plus 32. So again, I've just multiplied this out to get this, okay? You could also do it by distributing, okay? So like that means this times this, that's going to give you x squared. This times this is going to give you a negative 4x. This times this is going to give you negative 8x. This times this is going to give you a 32. So you could do it that way, or you could do it the box way. All right, so my last step is to distribute this. Remember, we're not rude. We say hello to everybody. So that's going to be 2x squared. Say hello to the next person. 2 times negative 12 is going to be negative 24x. 2 times 32 is going to be positive 64. Now there's nothing left to distribute. I have it in standard form, which remember, this is what I'm looking for, ax squared plus bx plus c. So I'm ready to put in my answer into standard form. So multiplying polynomials is how you get factored form, which is this one, or vertex form into standard form. And again, just be careful with what you're typing in to make sure that it matches exactly what you have. I'll do one more, maybe something that looks a little bit harder. Okay, so they all look pretty easy. I'll just do one with a negative outside. Maybe I'll just do it with a negative 1. There we go. Let's do this question. So again, you want to get it into ax squared plus bx plus c. Just make sure that it's in standard form when you put in the answer. So let's go ahead and do, so again, I have this negative outside, and then I have this times this. So I'll start off with this times this. So I'll start off with the box, which has x minus 8 on the outside and x plus 9 on the top. right, so let's go ahead and multiply them out. So what's x times x? X squared. Negative 8 times x is negative 8x. X times 9 is 9x. Negative 8 times 9 is negative 72, because a negative times a positive. All right, and again, once you get to this step, you're combining the like terms. If you organize this in order of degree, it's always going to be the diagonals. So we're going to write the answer out. Remember, this part is this answer right here. So I'm going to have that negative right outside. And what do I have left inside is after I multiply these two. So it's going to be x squared. Combine like terms right here. Negatives are made in positives. They're going to fight. Positives win by 1. And then this doesn't combine with anything. So last step is to go ahead and distribute. This is going to be negative x squared. Distribute it to there. Negative times a positive, or negative. Negative times a negative, which is positive. Okay. Then once you have your answer, go ahead and write it out. There's nothing else to distribute. There's no parentheses left. Just make sure that you type out exactly what you have on your paper. Just double check your answers to be careful. All right, we're going to take a look at parabola features. All right, so this is really understanding what each thing tells you, or understanding definitions. Okay, so there are different questions that they can give you. So this case, it's the y-intercept. I'm kind of just going to speak about all of them. I'm just going to see what all the different problem types they can give you, so I make sure I can go over it. So I'll do it from here. All right, what is your y-intercept? Where does it cross over the y-axis? So here's the y-axis. Where does it intersect with the y-axis? At -5. All right, so when you put in your answer type, you have a choice right here. You can say, is it 2 points? No, because it's just crossing at -5, right? Is it 1 point? Yes, you could write this as a point. Or is it one equation? Actually, I'm curious to know, because you can write this as two things. So let me show you. Hopefully they show you. So you can write it as one coordinate, which is 0, -5. And I wonder if they'll accept an equation. So I'm going to type it in and see if they'll accept it. Okay, so show question. So it's 0, -5, or if I put it as an equation, y equals -5. I'm just going to check to see if they're going to accept the equation part. But it is a point 0, -5. Okay, they will not accept an equation, so it has to be as a coordinate. So it's 0, -5. All right. All right, what if I'm looking for the x-intercepts? So I'm going to look where this graph, the blue graph, crosses the x-axis. So this is going to be at 4 and at 6. And how do I write that as a coordinate? It's going to be 2 points because it crosses twice, at 4, 0, because it goes x and then y, and at 6, 0. All right, so we've done y-intercepts, x-intercepts. Let's do another one. So we did x, y. Let's do coordinate at zeros. All right, so coordinates at 0. So remember, there are 4 different ways of saying the exact same thing, right? So x-intercept, solutions, zeros, and roots, right? 4 different ways. They all mean the same thing. It just means the x-intercept. So what are these x-intercepts? There are 2 places that it crosses the x-axis. So there's 2 points. They are going to be at -7. So how do I write that down? -7 for x, 0 at y, and -5 for x, and 0 for y. So again, 3 different words that mean the same thing. X-intercepts, where it crosses the x-axis, roots, solutions, and zeros. I think I said the 4. All right, so perfect. So same thing over and over again. All right, so we've done y-intercepts, x-intercepts, zeros. Let's do vertex. So what is the vertex? The vertex is where the minimum or maximum occurs. So that point is right here, in this case, right here. So what is this in terms of x and y? It's -5 and -9. So the vertex is 1 point, all right, which is -5 and -9. So this is just knowing your definition of what a vertex is. All right, let's do another one. All right, coordinates of a vertex. Similar problem, because I already had a minimum. I just want to do one that's a maximum. All right, so maximum, again, the vertex is either the top or bottom of the graph, which is here, the top. So this is going to be 1 point, and the vertex is -6, -6, and +1. So you put your x value first, -6, and then your y value 1. So -6, 1 right here. All right, and then the last thing that we're going to take a look at is your equation of axis of symmetry, and the key is in the word equation. Anytime you see an equation, there should be an equal sign. So points are not going to give you an equation. Equal sign. And when you have this, you need to put an equation. So determine the equation of the axis of symmetry. What does that mean? Where it crosses, where it splits the graph exactly in half. So symmetric means like it looks the same on both sides. So if I drew an invisible line right here at -2, it would split the graph exactly in half. They would look the same on the left and on the right. And remember, it must be an equation. So I do not put -2 because -2 doesn't mean anything. It has to be because this is a line. X equals -2 because it goes through it. So x equals -2. So again, where do I split the graph? Into exactly the same on the left and the right. I'll do one more. Let me do a maximum this time just to make sure that you understand it doesn't change. So it's just definitions. Okay, axis of symmetry is where you draw your straight line to split the graph in half, right? Which is right here. So you come right here. It's when x is equal to what? 2. And remember, it is an equation, so you must put it in as an equation. X is equal to 2. All right, I think I went through all those definitions. All right, so we're going to take a look at finding average rate of change from a table, equation, and a graph. And really, if you can do one, you can do all. All right, the table is easy. So remember, average rate of change, you need box. So in my case, you're going to do parentheses. Then it's parentheses minus parentheses over. So I'm going to do divided first. So you got to do divided so I can do that. Parentheses minus parentheses. All right, then minus parentheses. So once you have that set up, parentheses minus parentheses over parentheses minus parentheses. They're always going to give you the x values. And remember, we're going off of, what is this? Slope, right? Average rate of change. So if you go look right here, average rate of change, it says the change in the y divided by the change in the x. And if you look to the left, they give you the values. So you can see x on the bottom, y on the top. So x on the bottom, so x, and it looks like it's which x? x2 first, so the second one. So the second one is 13. So 13, and then the first one, which is 4. So x on the bottom. Then all you have to do once you put that in is match it for the y. So I'm going to go look for 13 in the table right here. What's the y value? 30. So you're going to match that to 30. Then you're going to match 4. What are you going to match 4 to? 48. Once you put it in, that's your answer. You're done. All right, so that's from a table. Then when you do it from a equation, it's the same thing. You're just going to copy and paste it. Control C. And I'm going to leave this up here because I need it. Control V. All right, then, fix whatever needs to be fixed. Like, I don't need that at the end. All right, something has come up. All right, so once I get an equation, now that I know how to do it from a table, all I need to do is make this a table, right? To make that a table, click on the settings, hit table, and now it's a table. And now you're looking for your intervals again. So once again, I'm going to delete this. So it's parentheses minus parentheses over parentheses minus parentheses. Make sure that that's what it is and not this. This is something different. If you have this would be wrong, okay? So make sure that that division bar goes over the whole thing. All right, so now I'm looking for, again, the first number, if you forgot, is the second x and then the first x on the bottom. So second x is 11. So that goes right there. First x is 3. And then match it. So I don't see an 11 here. Oh my gosh, just come in here and type it. 11 is 21. And then 3, if I don't see a 3 there, just come to any number, type 3, it's 53. So once again, it works it out for you, and that's -4. All right, so all these questions are really the same thing, but from 3 different values. So we're going to take a look at the last one. All right, so looking from a graph, again, the same kind of idea. All right, so what's my second? So I'm going to come to my boxes here or my parentheses and delete all the numbers. All right, and they tell me my second one is 2. That goes over here. And again, if you forget, just come to the formula sheet right there. In fact, I should do this. All right, so right here, the second one goes first in the bottom. So 2, and then the first one in here. And you just have to find what those matching equivalents are. So when x is 2, what's y? So when x is 2, right here, y is 0. When x is 1 right here, I go up to the graph, y is 10. All right, so again, to read the graph, you just go to it. So when I'm finding x is 2, I go right here, y is 0, y 1. When x is 1, it's 10. If x was 7, I'd go to x is 7, go to the graph, and then y would be 40. If x was -2, for example, I'd go to -2, go to the graph, and y would be -32-ish, but they won't ask you for something in between. And that's pretty much how you do all of those questions. So you can do all of those questions relatively fast. All right, so all of these, the next like 5 or 6 are the same exact thing. That one's easy. We're just copying and pasting in here. So Control C. So first of all, I'm not copying and pasting all of this. That's too much. What I'm gonna do is just look. This is a happy face, so all the positive ones might be the answer. So Control C, Control V. To kind of fix this, I'm going to Control X here. Control X is cut. Control V is paste. Okay, so that's the first one. We're going to see if it looks just like that. All right, so actually, I'm going to paste all of them in here. Control C, Control V. All right, so again, Control X will delete, Control V will paste. So they look really similar to that one. I know it's not these two because these are sad faces, so I'm not going to put all of them in there because it's taking too long. All right, but I need to look for the one that crosses at, looks like -6, right? So I'm going to zoom in. This one, blue line crosses at -6. That means this is the answer, so this one is the answer. All right, so for all of these questions, we're going to do the exact same thing. So all we're doing again is we are copying and pasting in. So here we go. We're going to do this 4 times. Control C, Control V. Again, to copy it, Control C, Control V, Control C, Control V, Control C, Control V. Okay, so find the house thing on the side right here. I think it'll zoom in everything. Where's the other one? Oh, something's up with this one. Oh, there's a Y. So you see, I know that there's something wrong there, so I'm going to delete all of that. Boom. So therefore, all right, so it's to the left of this, and it's a happy face. So it's this one. So this equation is highlighted as the answer A. So you're just matching it. So it's none of these two. It's not this one because that's on the right-hand side, and then it's just that one. All right, so copy and paste into the Desmos calculator. It'll do the rest. You're going to put it in, and then you're just going to see which one it is. So again, this is a happy face. These are all happy faces. So in this one, it might be any one of them. Now, there's, of course, a faster way of doing this. We've done this in class, but for right now, we are just using the Desmos calculator, so I'm not really going to go over it, even though it is faster in my opinion. All right, so again, Control C, Control V. I'm going to do all of these at the same time. Control C, Control V, Control C, Control V. And then I'm going to come fix all of them. So that's 2 squared, X out of that, Control X to delete, Control V to paste. This one is squared, X that, and it's just +6. I can write that in. All right, X out, X out. This has got too much stuff. Delete, just, make it match. Delete. All right, now just check your equations, make sure they're the same thing. So -6 +6 +6 -6. Okay, cool. All right, so that's on there. Where is my equation is the question. So we're going to press home. So it's going to zoom in, and you can see 4 different equations. It's not these, so it's not purple, and it's not red. So I can click out of red, and I can click out of this purple. So you see when I click that, that's highlighted. That's gone. So it's one of these two. It's not the one that's above the x-axis, so it's not this one. So it's got to be this one. Okay, so again, if that doesn't work, you can look at the intercepts. You can look at the vertex, so you can make sure -5, -6. You can do through all of those. So it's the one with the -6 and 4 in front, x +5. That's this one. All right, so we're going to take a look at select form to find the quadratic feature. And of course, all of these things that we can find. So I'm going to focus on the y-intercept. Okay, so remember, if I'm looking for the y-intercept, what is the fastest way to get there? All right, standard form is the fastest to get to y-intercept. Factored form will get you to the x-intercepts and whether it's positive above the x-axis or negative below the x-axis. And a vertex form will get you to, vertex is your maximum value or your minimum value. It'll also get you to your axis of symmetry goes through the vertex, and then you can look at increasing and decreasing left and right. So in this case, because I want y-intercept, I definitely want standard form, because as soon as they write it in standard form, I can see my y-intercept is negative 48. So there's one y-intercept at negative 48. Do they want this as an equation? Let's see. You must find the y-intercept, choose the form you'd like, or it doesn't really say, so let me just put negative 48. As the y-intercept, so it's 0, negative 48. Not quite sure how they want it as an answer, so we'll try this and see if they want it this way. That's how they want it as a coordinate. All right, so y-intercept standard form. All right, let's go to x-intercept. So again, what form would I want? Let me just remind you, standard form is y-intercept, factored form is x-intercepts, as well as positive and negative. Vertex form is maximum or minimums. Going through the vertex is also your axis of symmetry, and then increasing and decreasing. So remember, vertex has the most. In this case, I'm looking for x-intercept, so I'm going to go to factored form. Remember, to pull your x-intercepts, it's whatever is in the parentheses, just opposite. So how many x-intercepts are there? There are 2, because there are 2 parentheses right here. So the first one, opposite. So what is opposite of positive 6? Negative 6. And again, everything goes into your parentheses. So negative 6 is x, and 0 is your y. And then same thing on the second one, only it's negative 2. So negative 2, 0. So just remember, when you're doing anything inside the parentheses, always opposite of what you think. I'll do one more just to make sure that you're fine. Again, if it's x-intercepts, the form that you are looking for is factored form, because it gives you the x-intercepts. These are 2 parentheses, so there are 2 x-intercepts. The first one is going to be opposite of whatever is inside, because remember, anything inside is always x and opposite, right? So x is equal to positive 3, so x is 3, y is 0, because it's intersecting at that point. And on the second one, I have it at negative 1. So x is not 3, but now it is at negative 1. So just don't forget to take the opposite of it and write it in coordinates, right? So that's y-intercepts, x-intercepts. Let's talk about maximum or minimum. So remember, when is there a maximum at the top of the graph? When is there a minimum? What is that called? That's called vertex, right? So I'm obviously going to be looking for vertex form, because that's where my maximum or my minimum occur. And when I get this value, remember, so your vertex form is one coordinate, and this is going to be your x because it's inside, right? But opposite, so that's going to be 1. And then outside is going to be your y, just like it is, y and regular. So that's going to be negative 25. All right, so that's where my vertex occurs. Did I need to do something else? Oh, they're just asking me what the minimum value is. I'm sorry, I did not read the question. So I wrote down what my vertex was, but the question is, where does my minimum occur? So my vertex is at 1, negative 25. That minimum is going to be at negative 25, the y value. So I apologize. I'll do another question. I obviously should read. That would help. All right. So where's my maximum or minimum? It's going to be on my vertex. So my vertex is actually, so my x value is positive 4. My y value is 12. So they're asking me where that maximum or minimum occurs. It's just the y value. Okay. So just the y value in this case. So they're not actually asking you for the vertex. All right. So let me do one more, because these are really quick and easy. Max and minimum. Right, so maximum minimum is always your vertex form. And again, my vertex happens at 4 and negative 3. Because they're only asking what value is my maximum or minimum, it happens at the y value of negative 3. All right, parabola A value. This one's actually pretty easy if you just have to remember it. So the smaller the number, it's going to be opposite. The smaller the number, the wider the graph. So for example, if the number is 1, and I have a graph like this, if I have like a half, it's going to be wider than this. It's going to be wider, right? So the smaller the number, the wider the graph. Okay, with that being said, you have to arrange these. So I would first start with, first of all, if they're happy or sad. They're all sad, so they're all facing down. That doesn't help me. All right, so then now look for the smallest number. It's going to be the widest graph. So this is the widest graph, right? That's going to be the smallest number. All right, so if I drag that to the smallest number because 0.25 is smaller than everything. The second, oops, I didn't grab it. The smallest number, the widest graph, okay? Then the second smallest number will have the second widest graph, I guess. Or we can do the largest number will have the narrowest graph, whichever way you're going to look at it. So this is the largest number, so ignore the negatives. This is the largest number, so it should have the thinnest graph. Okay, I'm going to do another one because I want to make sure. Okay, so I'm going to get that wrong. So I can do another one. All right, so again, we're going to start with the smallest graph is opposite, right? The smallest number is the widest graph, widest. So find the widest graph here. This one's the widest. We're going to put that there. All right. Notice all the negatives are telling you is whether they're happy or sad. These are both sad. This is happy, so it was the only one it could be anyway. All right, then you can do the largest the number, the thinnest the graph. So which one is thinnest out of this one? These, okay? I'll do one more, so let me get that one wrong. Next. All right, so let's start with positives and negatives so that it's easier. These are both unhappy, and this is happy. So the only happy one is this one. So now it's between these two. Again, the smaller the number, the wider the graph. So now I'm looking at these two graphs. Which graph is wider? This one is wider, so it'll be that way. Okay, hopefully those three questions were enough for you to understand the concept. The smaller the number, the wider the graph. All right, we're going to take a look at quadratic problems, profit and gravity. There are a few questions that you could get. It really doesn't matter. The big thing, and I'm actually going to go over all of them just so that you understand. You copy it, Control-C, you paste it into the calculator, Control-V. It does this weird funky thing. Just correct it. So here should be Shift-6 squared, and then I'm going to copy this, Control-X, paste it, Control-V. All right, so now I have it copied. Make sure, again, it's copied exactly. So negative 16x squared, 157x, and then 105. One is copied exactly, you're good. Now they are, looks like 1, 2, 3, 4, 5 different questions that you can get. So it's about reading the question, okay? So I'll actually answer this question, then answer the other 4. So let's read it. A rocket is launched. So that means it's going to go up and then it's going to go down. So if I zoom out, and this is zooming in, this is zooming out. So I'm going to zoom out till I see it. So boom, zoom out. So it's launched, so it's going to go up and then it's going to come down. Okay, so that's already ready to go. The height of the rocket, y. So they're telling you y is what? Height. So if they ask you for height, you look at the y-axis. Is related to the time after the launch, x in seconds. If they ask you for time, you're looking at what? X. By the given equation. Using this equation, find out the time. So if they're asking me for time, find time, and what's time? X. So that means they're asking you for the x value where the rocket will reach the maximum. So you have to know what maximum is. What is the maximum? Maximum is the very top of your graph, right? I'm going to zoom out. Looks a little weird, but that's okay. Click on it. There is my maximum. Now, which one of these is my maximum? So remember, you have to read the question, right? What was the question asking you? It said that time for it to get to the max. So time is which value? X. I have 2 possible values right now. So what is the time? The x value, 4.906. Now, if there's any rounding, this is where we have to round. So 4.906. All right, and it says round to the nearest hundredth of a second. What does that mean? There are 2 zeros. That means this right here is my cutoff point right here. I cut that off. I should only have 2 numbers after the decimal. What does this 6 do? 5 and above, add 1 more. 4 below, let it rest. So this is 5 and above, so add 1 more. So this 6 adds 1 more. Boom, done. All right, so what did I do? This was the time for height. Let me actually just go in order and just do a whole bunch. All right, so let me find the profit. So again, Control-C. And all of this one is just reading, Control-V. X out of all the extra things. These were a lot. That's fine, just x, 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 x. All right, so this is squared. So I can X out of that one, and then Control X, Control V, make sure that it's pasted exactly. It is. Now, again, let's read. Using this equation, find out the price. So I need price. I need to know is price X or is price Y. So the amount of profit Y, okay? So profit is Y, and the price is X. So whatever I do, I put in the X value. All right, so let me see the question. What is the price the widget should be sold for to the nearest cent for the company to make the maximum? Again, where does the maximum happen? At the very top. And again, what did I want? The price, right? Which was my X, because it told me in my question, X. So it's 26.75. Real simple. All you have to do is just read it and understand what it's asking to match it. All right, now round to the nearest cent. What does that mean? So if the nearest cent means I should have cents, which will be two numbers after the decimal. All right, do I have two numbers after the decimal? Yes, I do. I don't have three, so I don't need to cut anything off. So I am done. Again, I'm going to go through like every single question that you could possibly get so we could make sure that we understand. So copy, Control C. Control V is paste, get rid of all the extra stuff. That one was a lot. Boom. This is squared. And then I'm going to Control X and Control V. So make sure it's copied and it looks exactly the same. All right, and again, now I'm just going to read the question now that I know what the process is. Using the equation, find the maximum amount of profit. So I'm talking about the maximum. So I'm going to zoom out, zoom in. Here's my maximum. Okay, there are two numbers that could be my answer. Which one do I want? I want the one that says profit. So let's read the question, find out what profit is. Profit is Y. Price is X. So profit is the Y value. So this is the Y value that I'm going to type into my answer. 7337.862. All right, this is my profit. Round to the nearest dollar. What does that mean? They want no change, right? No 25 cents, no 2 cents, no 98 cents, nothing. No change, which means there should be no numbers after this decimal. All that needs to disappear. So before I disappear it, I look at the number after the decimal. 5 and above, add one more. 4 or below, let it rest. So 8 is going to add one more. So it's going to add one more to make this 7 into an 8. All right, so I'm just going to keep doing them because all it is just reading the question, okay? Again, Control C, cross out these, Control V. It's going to give you a whole bunch of gibberish, X out of everything. All right, change the question. So this would be squared, Shift 6, Control X, Control V. Make sure the question's exactly, yep, it is. I'm good. All right, find it. So I'm going to press home to kind of find it and kind of zoom out. There we go, and kind of go to the top. You zoom out, and I'm dragging the mouse and going down, dragging it, going down. Zoom out, zoom out, zoom out. Dragging, 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 dragging. There's the top. In case I even need the top. By the way, I might not need the top. Let's see. All right, using this equation, find the time. So time, I need to find what time is. Height is Y, and time is X. So find X. So whatever I get, find X. It takes the rocket to hit the ground. Okay, so let's think about this logically. The rocket goes, okay, whatever. Zoom out, zoom out, zoom out. This is not a good example, but okay. The rocket's going to go up, right? But it's going to run out of gas and start doing what? Coming down. So they're asking, what time does it hit the ground? So let's talk about that. When does it hit the ground? Right here. It hits the ground when it hits the ground, right? So the x-axis is the ground. And what's the time that it hits the ground? So remember, let me go find what time is. What's time? X. So when it hits the ground right here, what's my X value? So you just type it in, 15.514. And then round to what? 100. 100 means 2 zeros, so two numbers after the decimal. So I need to get rid of that number. Before I get rid of it, I have to ask 5 and above, add one more. 4 or below, leave it alone. So 4 and below, leave it alone. So we just delete that. We leave it alone. And we press submit. All right. Let's do another one. All right, again, Control C. And I'm just doing the 5 different problems because they can ask you 5 different questions. I'm just reading the question to you to make sure that you understand it. But the process is all the same thing. All right, so again, make the equation look the same. Shift 2, Control X, Control V. Make sure you copied it correctly. I did. All right, let's go look at the question. Find the time. So I need to know what time is. Time is what? X. So I'm only looking at X. where the rocket reaches where? Maximum. So that means I need the maximum. So you got the maximum of the graph. You have two numbers there, right? You have two numbers there. You have the maximum right here. And I need that x value because I need time. So I'm going to say x value because of time. It gets to the maximum point. So maximum point by definition is the top of the graph. All right, so once I have that, I put that in. So that's going to be 5.3. I guess I should move it over here. 344. Round to the nearest hundredth. So two numbers after the decimal. That means I don't need this number. Before I get rid of it, I ask 5 and above. Add one more. 4 below. Leave it alone. So I'm leaving it alone because it's 4. So I just delete it. And that's how I answer it. I'm on the last question, I believe. All right, so here's the last type of question, because remember, the question is going to change, right? All right, so I do Control C and Control V. Get rid of all this extra stuff. All right, so this needs to be squared. Shift 6, Control X, Control V. All right, and again, now read the question. Find the maximum height. I need max, so this is my max. But there are two answers. I could get X or Y. What is height? So let's go find it. Height of the rocket is Y. So I'm looking for the Y value right here. All right, so the Y value is this. So I'm going to write it down just like I see it. 268.063. Okay, and this is to the nearest 10th. 10. So the number 10 has 1 0. So that means I don't need anything past one number after the decimal. So this needs to go away. Before I take it away, let's look at the 6. It's going to change this 0. So 5 and above, add one more. So because this is a 6, it is 5 and above. So I add one more. All right, that's the last kind of question that you could get. So 5 different questions that you could get with one question, and that's how you do that. All right, so you're just going to copy and paste the question. This is how you cheat it. Then you know vertex form looks something like this, right? It's one parentheses with an x in here and then some number out there. So you just got to go find the vertex and put it in. Now, I need to caution you and make sure that you understand this is only going to work when you don't have a number out here. So I hope I can get a question with a number out here so I can show you what's going to be different. But we're going to double check our answer and the graph to make sure that it's correct. So this is how you're going to cheat. So after you copy and paste, you can see now, again, be careful to zoom in because right here where I click, that's not the vertex, right? Let's make sure you zoom in so you don't get the question right. Here is the vertex, -1, 18. So first I'm going to put this in, -1 and 18. And now I just need to rewrite that. Remember, this is the x value, but anytime it's inside, it's opposite. So instead of being -1, it's going to be opposite, +1. And out here, 18. So plus, oops, sorry. On out here, plus 18. All right, now we're going to take this, put it in here. And if it matches, then we're in good shape. But what I'm going to do is just to make sure that it really matches. Okay, so I'm making it full screen so you can see. Take the blue out, put it back on. Is it exactly over the purple? Yes, it is. So this matches. I did this correctly. That's how you cheat. I am going to show you how to do it the long way just for sake of doing it the long way, and which I will show you in just a second. But that's pretty much all you're doing. All right, so can you take out the greatest common factor? Nope. So what you do is you rewrite it with an equal 0, right? Take this to the other side. So it's going to be -19 on the other side. What's left here is x squared plus 2x, right? That's what's left on this side. Then what you're going to do is set it up. So you're going to leave a little space and you're going to write, because you know vertex form looks like this, something like this, right? So you're going to leave it a little space and write that equals. All right, now you're going to do the 3-step process. What's the 3-step process? Divide by 2, which is 2 divided by 2 is 1. So this is +1. Take that answer, square it, square, put it right here. 1 times 1 is 1. Then my last step is multiply, and apply to the other side. 1 times 1 is 1. All right, then combine these. So negatives are made in positives. That's going to be negatives are winning by 18. Then my last step is to take it back. So this answer is x plus 1 squared plus 18. All right, now, again, you're going to take your equation. All right, we're going to do both just to make sure that we don't get it wrong, okay? So we're going to put it in x squared. Make sure that you put in exactly what it is, Control X, Control V. So this is my equation. If it matches to this, I'm good, okay? We need this in vertex form. I know vertex form looks something like this. one parentheses with an x inside. We just need to pull the vertex and put it in. So I'm going to zoom out. All right, there's the vertex. Be very careful to zoom in on the vertex. Click on it. So here's my vertex. So let's go ahead and write that in, 4 and negative 25. All right, how do I put it in my equation? You got to think backwards, right? Remember, when you're pulling it from the equation, your x value goes with the x, so opposite of what you think. So if it's plus 4 right now, it should be minus 4. And then your y value just goes outside. I'm just going to copy and paste it, actually. Boom. Now, I'm going to double check this because, like I said, if this was something else but 1, it would change my answer. But in this case, it's not, so it doesn't change my answer. Double checking. Now, I'm going to make this big screen so I can make sure that, I'm really checking. Is the purple line the red line? Purple, red, purple, red. Yes, it is. See, as soon as I cover it, you see how it goes right over it? Okay, so that is the correct answer. I can press submit. I'm good to go. I'm just going to double check to make sure that they are going to change. Let me just see. New problem. If this is bigger than 1, I just want to show you one little difference. But it's not, so I'm just going to tell it to you. It's not going to be on the test, but you might get this on the EOC. Let's say that you had 2 here. So I'm going to change this question a little bit, 16, and this is 18. Okay, let's say you had that. To write your difference of squares, it's going to be the same thing that you did before. However, you're factoring out this 2. Okay, so you're factoring out the 2. When you factor out the 2, what I'm talking about is this. And to put in a new line, let me just X out of that. When you factor out the 2, so this is, if this is not 1, right? You would write boom, boom, shift that, squared, and you're looking for your vertex. So this is my question now. So this, I'm just making a question up. All right, let's go get my vertex. So again, zoom in, make sure it's right. So my vertex is 4 and 50, negative 50. All right, 4 and negative 50. All right, now if I was writing this in, I would write x, and then because it's positive 4, I would write minus 4, right? So minus 4, and then this minus 50 is supposed to go on the outside, right? Let's double check this. So when I come here, Control C, Control V, you see how it doesn't line up? That's because we did not take out the greatest common factor, so it changes everything inside. Okay, so if you do get that question where it changes it inside, you just have to do one more step. So I'm just going to put it right here real quick. All right, you take out the 2 and then write out what is left. So what's left? X squared. So this is taking out the greatest common factor, minus 8x. And I'm just going to hide the green line. Minus 8x, and then minus, divide by 2 is negative 9. All right, now watch this. Is the blue line, so I'm going to make this big, is the blue line purple? Yes, it is, right? So I'm still good. Now what you do is you can now do this. All right, so I'm going to go and pull my vertex, which is negative 4 and negative 50, but now I have this 2 outside. So I'm going to see something. So if I put a 2 outside, see what I just did? All right, so I'll make it bigger real quick. Let me delete that. All right, watch it. All right, so if I put the 2 outside, this 2, because this is really this. I just missed this part right here. So if I put this 2 outside, watch. See what that did? It became the blue line is now the green line. So now I'm correct. So there's only one difference if x is not equal to 1. You do the same process, you put in the same numbers, but you just make sure that when you take out the greatest common factor. It may not be 2, it might be 4, it might be 5, it might be anything else. You just take it out and make sure that you put it in the front, which is why it's important for you to double check that both of your answers line up exactly. All right, next one, factor the trinomials, factor this completely. Okay, so we talked about this in class, but just in case you forgot, once again, Control C, Control V, come back and clean it up. And factoring is one step out. So when you plot the graph, remember to bring the graph into view, press this house key, whatever, it brings it back. So your solutions are negative 3. All right, so I'm going to write negative 3 is right there. And then the other solution is, what is this? Negative 0.3, 0. And it's a repeat in decimal. So remember, you got to let it pass the first one and go to the second one. So these are my 2 answers. To write my answers, okay, so remember we talked about having 2 parentheses, one with each one with an x, and then you put the opposite of your answer in there, right? So if this is negative 3, this would be what? positive 3. So this is the additional step you have to remember if you're going from solutions to factoring. This one will be, this is negative 1/3, so this will be what? Positive 1/3. Now, remember, you cannot leave it as a fraction, right? So what you have to do, or all you have to do, is take the bottom, the denominator, and put it in front of that x. So it'll be 3x plus 1. And you're done. Right? So 3x plus 1. All right, so that's the answer. I'm going to get one wrong, just so I can do another one. Or you could do all of this if you want to, whichever one's easier. All right, copy, Control C, and then paste, Control V. Get rid of everything that's not that. Make sure double check your answers. Yes, it is. All right, let me go ahead and set up my solution. So we need parentheses with x's inside. Then you need to go find your solution, which is negative 1.8. Also, we got to be careful with these, because if it is if it doesn't give you all that information, you're going to have to do it by hand. So one solution is 1, so that means this one is going to be a negative 1. And then another solution is negative 1.8. And I'm going to see if this is going to be right, or if it was a repeating decimal, right? So we're going to check it. But I don't think this is a repeating decimal. I think we're good. So again, you're changing the sign. So positive is going to become negative. And then negative is going to become what? Positive, right? But before we put that in, we're going to remember that we take the bottom and we take it to the x. So this is going to be 5x plus, because it changed from positive to negative, plus 9. All right, so we're going to check that out. So 5x plus 9. So, all right, so we're going to take a look at solve by trinomial factor. It's the same as factoring, only difference is it's actually your solution, your x-intercepts, your roots, or your zeros. Okay, so solve is you copy the same, x out of everything extra. So Control C, Control V, and then here we're going to make it squared. Then we're going to Control X, Control V. All right, once I have it, I'm going to actually solve it, not factor, which is actually a lot easier. Press home to see my graph. Here's my solutions right here. That's it. Oh, here's a problem. They're not going to want you to write it as 0. All right, so let's take a look at the solutions. The solutions are the x-intercepts. What does it cross? Negative 2. And what is this? Oh my gosh, it's a fraction. So we just have to write it in. So solve the quadratic by factoring. So the first answer is going to be, where does it cross the x-axis? Negative 2. And this is asking you for an equation, so I'm not going to put it as a coordinate. So it's negative 2, comma, because there are 2 places, right? And then the next one is this, but I can't put that in here. So it's negative, but it's a fraction of some sort. So I got to find out what that fraction is. So I'm just going to put it in as negative 0. And it's 666 repeating. So remember, for this, the trick is put the fraction, do it until it disappears. Then when it reappears, that's your actual answer. So negative 2/3. All right, negative 2 over 3. Okay. Now we're just going to check that. And how do I check that? I can say x equals negative 2. Right? So x equals negative 2. And you can see it has a blue line, which is sum. All right, I'll do another one. So again, copy the question, paste it. All right, boom, make sure it matches. Okay, that's good. Go get your answers, because it's asking you for the solutions. These are your 2 answers. So the first one is 1, comma. The second one is 2.5. But remember, we can't put 2.5 in there, right? So you're going to put 2.5 in here and make it a fraction, which is 5 over 2. So your 2 answers are 5 over 2 and 1. And I don't need to make these opposite because they're not going in the parentheses, right? So you just copy and paste in and looking at what the solutions are. Where does it cross the x-axis? That's it. All right, so we're going to copy and paste it into your equation. And look, there's an error. What's the problem? We only support implicit equations of x and y. Oh, because I put a w in here. So let's change all the w's to x. But when you put in your answer, just make sure you're using w or whatever the question says. X, perfect. So here are my solutions right here. Now, here's the problem. If my solutions was something that were repeating decimal, then I would be fine. But these are not repeating decimals. So my answer is irrational. And here's the hint that says a plus or minus. So I actually have to do this the long way, but I can do it using the calculator the whole time. All right, so I'm going to keep my original question here. I'm going to do Control C, Control V. All right, I'm going to do my work in decimals. Notice purple and red, same question, right? All right, so we're going to put this into the quadratic formula. To put it into the quadratic formula, remember you have to have equals 0 on this side. So what do? Take this to the other side. So if I take 6x squared to the other side, it's going to change from positive to what? To negative, right? So I'm going to x out of that, put it right here, and put negative. Now, did I change anything? So let's get rid of this equals, so because that's equals 0. Did I change anything? Look, it looks exactly the same, right? So all I did was take this to the other side. Now, let's combine like terms. So I have 11 minus 6. So 11 minus 6, so it's 5. All right, so let me change this whole thing to 5x squared. Did I change anything? So look at it. Okay, so we're just using the calculator to still do our work. Now I can see this is an ABC form. Once it's in ABC form, I can just go and put it into the quadratic formula. So you're going to go into your formula sheet and you're going to find where it says quadratic formula. All right, quadratic formula right here. And you're going to type it in as you see it. Okay. So I'm going to type this into my calculator. So I have minus b, and because I have this fraction, I'm going to put the fraction in first. So I'll put divide. On the top, minus. Instead of the letters, I'm going to put parentheses. I cannot put plus and minus, so I'll start off with plus, and then I'll put minus after. So now square root. So square root. And then I have b squared. So b squared minus. And again, anytime you see the letters, go ahead and put parentheses in their place. Minus 4. And then I see a letter again, so A and then C in parentheses, all over 2 and then parentheses. All right, so again, I'm just typing this. I'm just typing this here with the letters as parentheses. Because once I do that, I know what A, B, and C is. This is A, so everywhere I see A, I'm just going to copy that. Where do I see A? Here. Paste A, paste A. All right, where do I see B? So I'm going to take B. Make sure you also take the symbol, so copy. And wherever I see B, which is here, is B, and also B is here. And then finally, wherever I see C, make sure you take the symbol with you. So the only place I see, the only place I see C, let me make this bigger, is right here. All right, boom. And notice, right, if I have plus, so let me go check my answers to make sure I did this correct. One of the answers should be 1.881, which is true. And then if I have minus, so if I change this to a minus, the other answer is 0.31, which is also true. But you see, this is not a repeat in decimal. So this is the problem that we're running into. So you have to simplify all of this. But again, you can do it inside the calculator. We're going to take everything that is under the square root, everything right here. And we're going to paste it right here. In fact, I just need to make this bigger. 61. Remember, everything I took underneath here, all of this is this right here, right? So I can replace all of this, everything under here, with 61. Now keep an eye on this number. Should not change. 0.031, etc. So I'm going to take everything underneath and put that there. 0.031, etc. So I'm still good. All right. Now I'm going to take this. Let's make this into one thing. A negative times a negative is what? Positive. Again, keep an eye on this right here. It should be positive 11. Do I change? No, I'm still okay. All right, let's take everything underneath. So we're doing it step by step. Not the parentheses, the radical, the thing at the beginning, and then everything underneath. The underneath, 2 times 5, 10. So I'm going to replace this with 10. Again, keep an eye on this number. Should not change. Did not change. So I'm still good. I got one more step to do because I have to simplify. The question says in simplest form, I'm pretty sure somewhere. Yep, in simplest form. So we have to simplify this radical. All right, so we have to do books. So 61. All right, we're going to break down 61. 61 divided by 2 doesn't work. Divided by 3 doesn't work. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, and by 14, 15, 16. By 14, 16, 17, you should have found the number if you can simplify it. So 61 does not break down into anything. The last thing I need to check is, can I simplify top and bottom? So this Can I do 11 over 10 and it simplifies as well as 1 over 10 and it simplifies? Let me check. 11 over 10. All right. It still stays 11 over 10. So because the first one doesn't simplify, the second one does not, which means that this is my answer, plus and minus. So I'm going to copy, paste it, and then change this to plus and minus. All right, I'm going to do a different one that does simplify. So let me actually kind of cheat and find one that simplifies. So go ahead and copy the question down, change all the B's into X's. All right, so again, remember, as long as it stays this way, I'm good. So I'm going to take this right here, take this to the other side. It's going to change from positive to what? To negative, right? So on this side, it's going to be negative. And now I have nothing there, which is 0. So notice, and why is this in red? Let's not do red. I'm just going to take my answer and put it back here. It just needs to be a different color. Notice blue and red are the same exact thing. So I know I've done this correctly. So this whole time, you're going to just keep doing it and checking to make sure you're right. Okay, so I'm right. Now, this is my answer. It's not a repeat in decimal. So, oh my gosh, I actually have to put it into the quadratic equation. So put it into the quadratic equation just by copying the quadratic equation exactly how it looks, but in place of the letters, you're going to put in parentheses. So there's a fraction, so start off with division. Then on the top, negative, parentheses, because that's a letter, plus square root, so radical. Inside the radical, make sure everything's inside the radical. You have b squared. Come back out, 4, or minus 4, and then a, c, and then on the bottom, 2a. So everything in parentheses, okay, everything in parentheses so that you're matching everything up. Now you're just going to go get a, b, and c. But before I got too many numbers here. So let's go ahead and take this. And again, I'm just going to double check. I'm going to put this on the line below. I'm going to double check that my question does not change. So combining 23 minus 6. So we can combine that. That's going to give me 17. So I'm going to replace this with positive 17 and just make sure it doesn't change. Red and blue are still the same, so I'm still okay. This is my ABC. So my A's, where does my A go? A just goes here and here, so I'm going to put it there and there. All right, where does my B go? Make sure you copy the actual sign as well. So B goes here and here. And where does my C go? C goes here. All right, so boom. All right, double check that. So let's see. One of my answers is negative 2.29. Negative 2.29. Yep, there it is, right? 3, because it's rounded. All right, so I just need to simplify this. So this is now what I'm working towards to simplify. So remember, we're going to take everything underneath the radical. Well, I guess we can even go in order. Let's do this part first. We can go in order. So this part right here, negative and a positive is going to give me what? Negative, right? So make sure, check this number out. Doesn't change. So I should have negative 12 here, and it should not change that number. Boom, I'm good. Let's take everything underneath the radical. All right, everything underneath the radical is going to be 8. So I'm going to take everything underneath this radical and change it to 8. Nothing changes. Let's take everything underneath the fraction. It's going to be 4. So again, keep an eye on this number. It's going to be 4. Nothing has changed. So far, I'm so good. It's really when you get here, now you have to break this 8 down. So how does 8 break down? So let's check. 8 divided by 2 is 4. So this is right here, 2 times 4, okay? How does 4 break down? So let's see. Let's do 4 again. 4 divided by 2 is 2. So this is 2 times 2. So this is my breakdown. Notice my number is not changing. So you're finding out, make your cards so you can make your books. How many cards make a book? 2 cards, right? So 2 cards make how many books? 1. So I'm going to take that out and put 1 book outside. Again, my number is still the same, so I'm doing this correctly. My last step is to check if I can simplify these 2 right here. As long as both of them simplify with this 4, I'm good. So is there a number that goes into 1, 2, and 3? These 3 numbers right here. Yes, 2 does. 2 goes into how many times into 12? Into 6. Again, the number is going to change because I have to finish all of it. 2 goes into 2 how many times? 1. 2 goes into 4 how many times? 2. And look at that, my number is back. So this is my final answer, and this is going to be an invisible 1. So I'm going to copy that, and then I'm going to paste it with a plus and minus. So change that to a plus and minus because that's what the original question had. So that's how you simplify. All right, we're going to take a look at transformations, okay? And the only ones we're going to look at are the ones we're dealing with in Algebra 1, which is quadratic and square root. We actually do absolute value. So I'm going to put absolute value as well. So everything but generic, okay? Because it doesn't matter what it is as long as you know the rules. If you don't know the rules, go and watch that video where I go over the IXL, because I don't have the time to explain all of it. We're just going to do it via the calculator. All right, so really, to do this via the calculator, you need the original question. All right, so this is the original question. Let's see, copy. Let's see if it'll paste it. Yeah, it pasted, so we're just going to X out of the rest. All right, cool. Let me make sure the graph is here. Home. I don't see the graph. So it must not like something here. So there's an error. Okay, they don't understand the L symbol, so we're going to have to manually put it in. So come right here, find absolute value right here, and it's X. All right, now it's there. So you're going to have to manually put that one in because it doesn't like the copy and paste. Boom. So this is the original one. We need it to come right here. Okay, but these are our options. So what we're going to do is we're going to take our options and see which one is going to give us our answer. So let's start with this first one. And again, it's not going to like the copy and paste, so I'm just going to do it manually. So I'm going to paste this here, and it's supposed to have a negative outside and a -1 in there. All right, so does this graph right here look like this one? No. So let's try this one. This is a negative outside and the -1 is inside. And you're just putting in the answer choices C. So does this graph look like this? No, because it looks like it went to the other side, right? So let's try this one. Negative x plus 1. I'm going to try this one actually so I don't have to erase. Plus 1. Okay, this might look like it is. Is it? So let's take another look at a point. So we've got -1, 0. -1, 0. And then we've got 0, -1, 0, -1. This is it. This is the answer. So this one is the answer. So you're just going to put in all the answer choices and see which graph matches up. To me, it's faster just to do it by hand. But again, it really doesn't matter. So you're just going to put it in and see which one matches up. So we're going to start off with the original equation. I really don't even need to do that. I can just put in the answer choices, right? So we're going to X out of these, square root. I'm just putting in the answer choices and sees which one gives me the dotted line. So we've got x plus 4, and then you come outside. Make sure you come outside, plus 3. And does it look like this? So this point is at -4, 3. Is this -4, 3? Yes, it is. And is the y-axis, does it cross the y-intercept at 5? Yes, it is. So it just so happens the very first one I tried is the answer. And so you're just going to hit submit. All right, so you're just matching it up because now you're using a calculator. Doesn't matter what the question is. I'm going to show you one more. We did absolute value already. All right, here's another question. So I need to make it look like this. So we're going to type this in. And I think it will let me copy and paste this. Let's see. All right, so it's squared plus 2. All right, so again, once you copied and pasted in one of the answers, okay, does it look like this? It kind of looks like it's on the right. Is it at 1, 2? Let's see if it's at 1, 2. 1, 2, yeah. Does it cross at 3? Let's see, does it cross at 3? It does. So the first one I put in happens to be the answer. So you're just going to keep putting in your answer choices and see which one matches up. And that's all you have to do for that. All right, go take a look at compare features from tables, graphs, tables and graphs. So here's a graph and here is a table. What you want to do is find what questions below. Okay, so here's a question. All right, the maximum or minimum of f of x. So really important that you just know how to read the graph. So this says f of x, right? So when you're answering f of x, look there. And when you're answering g of x, look here. All right, so f of x. So let's take a look at f of x. Does it have a minimum or a maximum? So it has a minimum. Of f of x is, so what's the minimum value? Remember, it's just the y value, right? Which is what? -7. So the minimum value is -7. And there is no maximum because it's a minimum. Okay. Now I don't know if this is a maximum minimum. And I could show you how to put it, but I'm just going to show you since we're showing you via cheating. We're going to show you via cheating then. We're going to commit. All right. To put in a table, you're going to click table. So plus sign, table. Put in your values. Just make sure that you're very careful that you put them in correctly. All right. So if I keep pressing enter, it keeps putting it in, right? Then come right here. So it goes 6, 1, -2, -3, -2, 1, and 6. And you can already see it's a what? It's a minimum, right? So this one is the minimum value, and I need to know what that minimum is. So I can kind of guess these points, but I don't know if this one is the correct one. So I'm going to double check. To put that in, I know this is a quadratic. So what you have to do is you have to put in a quadratic equation. What does a quadratic equation look like? AX squared plus BX plus C, right? Now, here's the issue. See, I have an error. What it is it's saying, hey, there are too many variables, okay? Cool. I'm going to look on this table. I'm trying to tell the calculator, hey, look at this table and tell me the answer. So notice in the table I have x1 and y1. So I have to tell this calculator, hey, it's supposed to be y1, and everywhere there's x, x1. All right, I still have an error, and this is the only thing you really have to remember is for whatever reason it doesn't like this equal sign, you're going to click ABC and put squiggly line. All right, so ABC and quick squiggly line. As soon as you do that, notice what happened. It drew it for you, right? So now we can zoom in because it drew it for you. And my point is -1, -3. How do I know that? I'm going to take the equation again. All right, let me make this bigger, actually. I'll take the equation again. And now I'm going to put it back to, the y equals, because now I have the answers. I want to show you I have the answers, so give me a second. Boom. Okay, cool. This is the standard form, right? It tells you A is 1, so we're going to come right here. A is 1. And notice this black one should be the same as this red one, even though it is already. All right, 1, B is 2, and C is -2. All right, so notice how it's the same thing. So if it doesn't happen to give you one of the vertex points, I can see clearly it's -1, -3. So once you put in the table, so it's -3, my y value. There is no maximum because it's a minimum. I can just see it. All right, therefore, which one is bigger? All right, so f of x is -7. F of x has a smaller. So let's go up here. See, this is at -7, right? -7, this is at -3. So f of x has a smaller minimum, right? Because it's smaller. It's at -7. If it was bigger, remember with negatives, right? The smaller the number without the negative, the larger it actually is. So bigger numbers are up here. So this is -7, so a bigger number, -3. All right, we're going to do another question. And this time, since the table is already there for me, I'm not going to erase this. All right, so going to another problem. So I'm actually not giving you any of these, but you do the same thing. Put it in, look at the y-intercept, put it in, look at the x-intercept. But all I needed is actually a maximum and minimum. Comparing extremes of graphs, equations, and tables. Okay, so we're going to compare this, put this in order from smallest minimum to largest minimum. So take this. This is f of x. Put it in here. That's f of x, right? So you can already see the minimum is -4.5. We need a table, so we're going to come here, make a table. All right, so I have -4, -3, -2, -1. Then here I have 0, -2, -2 again, 0. And again, from a table, it's probably faster to do it forwards, but I am going to, again, like I said, I am going to show you. So again, we're writing in quadratic feature. So what does this look like? It's supposed to be y equals ax squared plus bx plus c. And it doesn't like it because it needs to reference this. So be careful. Sometimes it's not always 1, but in this case, it is 1. So wherever I see x and y, they're both 1. So everywhere I see x and y, I'm just going to go click on it and press 1. It still doesn't like it, and that's because of this equal sign. It doesn't want the equal sign. You're going to press ABC and do the squiggly line and delete the equal sign. Once you do that, you can see automatically it gives you a graph. I don't like red because they're both red, so I'm going to copy and paste it out again. So now it's in blue, right? So this is in red, this one's in red, this one is in blue, so you can see where the minimum is right there, right? This one, the minimum's right here, and the last one, the minimum is right here. So we're putting this in what? Smallest to minimum. Smallest minimum value to largest. Okay, so the one that's smallest is the furthest down, right? The smallest is the furthest down. So the one is this one is -8. What's this one? -4.5. So this one is this furthest down. So h of x should be first. So one of these two options. Next will be red. So red is this value right here. So I go back to see this value right here is f of x. So it should go h of x, f of x, then g of x. All right, so again, all you got to do is put them all in and look at it. Okay, so let's do a new one. All right, so boom, copy, paste. All right, squared. Make sure you copy it directly. Boom. All right, I'm going to change this table right here. Oh, I guess I'll just X out of that. All right, I'm going to leave this here. So I'm actually going to control X, but I'm going to come back to it. So put in the table. So this is -1, enter, 0, enter, enter, enter. And then on -1, it's 1, -2, enter, -3, enter, -2, enter 1. All right, so again, I had copied the equation, right? Because it's y equals ax squared plus bx plus c. Make sure the ones, oh, see this? It's not 1 anymore, it's what? 2. This was a perfect example. So make sure all these numbers are changed to 2. So they all need to be 2. Otherwise, it'll give you the wrong answer. So 2, because you're telling it, go look at this table, right? So 2, so that's the purple one, and then the last one is right here. And what are we looking for? Minimum values? Okay, cool. So the one that's the furthest down is the minimum value. So let's see. This one's -7. This one is -8. So this one wins. Green wins, which is this vertex form, which is f of x. So f of x first, one of these two. Then second would be, this one is -7. This one is -3, so -7 is next, so h of x. So it goes f of x, then h of x. And that's all you're doing. So just put it in the calculator and compare it. All right, last two pretty similar, difference of squares. So, and this only works if you have two terms. So this is the first one, this is the second one. And they're separated by a negative. So if they're separated by a positive, it will not work. But if you have two terms separated by a negative, and you can take the square root of the first one, and you can take the square root of the second one, then your answer is the square root of these two things, plus and minus. So for example, the square root of x squared is x. The square root of 144 is 12, and you can just put that in a calculator. So it's that plus and minus. That's it. Okay, so square root of the first thing, square root of the second thing with a plus and minus. All right, let's do another question. So I'm going to do a couple of these. All right, so again, you take the square root of the first, the square root of the second, plus and minus. So this is x, square root of x squared is x, square root of 25 is 5, and then you're going to do plus or minus. Just like that. All right, I'll do one more. So I'll do the actual question. So I already know I'm going to have parentheses. Square root of the first one. So square root of x squared is x. Square root, so I'm going to do it twice, right? And then the square root of 81 is 9. So I'm going to have plus 9 and minus 9. All right, so again, square root of the first thing, square root of the second thing, plus and minus. All right, for the last problem, it's going to be the exact same thing, only that now you have like more letters, I think. Yeah. And again, I'm going to do a few of these just to make sure that you're okay. So square root of the first thing, square root of the second thing. So let's square root this first thing. So square root of 36 is 6. Square root of x to the 6th power. Okay, so let's talk about that. What does x to the 6th power mean? It means you have x times x 6 times. Okay, x times x 6 times. And then when you square root that, right, remember square root is the opposite of squared. So you're going to go backwards. Squared is the same thing twice. So going backwards would be taking away the two things that you just got and making it one thing. All right, two things that you just did and making it one thing. Two things that you just did and making it one thing. So the square root of x to the 6th power is how many x's? 3 x's. So this is x 3 to the 3rd power. And then the square root of 49 is 7. So again, it's the square root of the first thing, the square root of the second thing with a plus and minus. All right, I'm going to do one more question on this because it's pretty similar. All right, square root of the first thing. Actually, I want a harder question. Let me see if I can get a harder one. Yeah, I'll do this one. Okay. So again, your parentheses, square root of the first thing. So y to the fourth power, what does that mean? It means I have 4 y's, right? 1, 2, 3, 4. So every 2 of them is going to become 1 if I'm going backwards. Every 2 of them is going to become 1. So I'm going to have 2 total. So square root of y to the fourth power is going to be y to the second power. And then plus and minus. And then the square root of the second thing. Well, the square root of 64 is 8. And again, you can just put that in the calculator. Hit 1, 2, 3, hit square root, and then hit 64 if you don't know the numbers. All right, so that one's 8. And then the square root of x to the fourth power. So again, that's having x how many times? 1, 2, 3, 4. And every 2 becomes 1, right? So that's going to be 1, and then that's going to be the second one. So it's going to be x squared.